Am I audible now?
Yes, sir.
Okay, okay. Then I'm audible, right? You can hear me properly. Yes, tell me.
Yes, sir.
Okay, okay. Screen is visible to everyone, right? I'm sharing my screen. Okay.
Yes, sir.
Okay. Okay. So we are aware about the topics that we are going to study, right? The topic that we are going to study is which topic? It's a non-CBSE topic, and that too we are starting with P block. Okay. Yeah. So in P block, we all know how many groups exist. There are total how many groups? From group 13 to group 18, but we are only going to study as of now. I am only going to teach group 13 and group 14. Later, the other groups will be taken by others. Sir. Okay. So, what is this title? Yeah. So in P block, there are group 13 to group 18 total, but we are only going to deal as of now with group 13 and group 14. Okay. Now, and that to what contents of P block? So introduction will be there. Then for each group, we are going to study their properties. Properties like which properties? Their atomic properties, physical properties, and chemical properties. Okay. First, we'll start with group 13, and then later on, we'll proceed with 14, 15, and onwards. Okay. Introduction. So, if you see introduction, so generally when we are talking about P block elements, it has wide range of application. And if I talk about only group 13, then also it has wide range of application. Okay. Now, what does this look like? Pencil. What is this? Pencil, no, graphite. Graphite is an electrope of carbon, group 14. Yes or no? Then what about this aluminum foil? You use it in your day-to-day life. Aluminum belongs to which group? Group 13. What is this? Anyone knows? क्या लिखा है यहाँ पे? What is written over here? A bulletproof vest. Do you know what is it made up of? Hmm? It has a material boron carbide. What does it has? It is a material of boron carbide, which makes it stronger. Okay. So these are the like applications that you can see in your day-to-day life for certain elements which belong to P block. Therefore, it is important for us to study those elements. Now, so generally what we have written over here, in P block element, the last electron enters the outermost p orbitals. A set of this orbital can have maximum of 6 electrons. Thus, there are 6 group of P block elements. We all know that p orbital, p subshell can accommodate maximum 6 electrons only. Is that clear? Now, from group 13 to group 18, we have total p block elements. Like this is the whole p block family. So starting from boron family, then carbon family, nitrogen, oxygen, fluorine, and ends with neon family. Okay. And what does this p block contain? It consists of metals, metalloids, and non-metals along with noble gases. Is that clear? Now, so if you see the general electronic configuration of p block element is what? NS2 to NP126. For boron family, it is NS2 NP1. For carbon family, it is NS2 NP2. For after that nitrogen family, it will be NS2 NP3. Oxygen family, it will be NS2 NP4. Fluorine family, it will be NS2 NP5. And then finally, when we go for noble gases, it will be NS2 NP6. Understood? Therefore, NS2 is common and this 1 to 6 is variable. Here it is changing. Now, how do you find about the maximum oxidation state? So, to calculate any element's maximum oxidation state, what do we do? Just remove its valence electron. What do we do? We remove its total valence electron. So, in this case also, maximum oxidation state shown by a p block element is equal to the total number of valence electron. And what is then the valence electron? Ns electron and np electron. So, if I ask you for boron family, what will be the maximum oxidation state? So you will say the electronic configuration is Ns2 Np1. Therefore, 2 plus 1, which is what? 3. For carbon family, what is the electronic configuration? Ns2 Np2. So what will be the total electron count in the valence shell? 4. Therefore, maximum oxidation state shown by the carbon family will be 4. Is that clear? Tell me. The non-metals and metalloids exist only in the p block of the periodic table. That is very much clear to everyone, right? Because S block have metal, D block also has metals only. So only P block is versatile, that it consists of metals, non-metals as well as metalloids. Okay. First member of P block differs from remaining members of the corresponding group in two major respects: size and availability of the orbitals. Are you aware which period we are talking about? When we mention this point that first member of P block differs from the remaining members of the corresponding group in two major respects: size and availability of d orbitals. So d orbitals are not available till which period? Can anyone tell me?
Three.
Right. Third period onwards it starts. No, till second period it is not available. So first period anyway there are two elements only, hydrogen and helium. Second period where we have eight elements. No. So for second period elements, they will vary throughout. Like let's say if I consider boron family. So boron family, what are the elements? Boron, aluminum, gallium, indium, and thallium. Boron is a second period element. Okay. And boron will show variable, like, it will show some different properties compared to the other group members. Why? Because it does not have presence of d orbitals. Is that clear? So therefore, it is written over here that first member of P block differs from the remaining members of the corresponding group in two major respects. Why? Because of the size and availability of d orbitals. Because in second period element, they don't have d orbitals. D orbital starts from third period and onwards. Okay. Now, see. So generally, in this family, no, in boron family, in group 13, the two elements that we have to study extensively is boron and aluminum. Is that clear? The two elements that we are going to study extensively throughout is boron and aluminum. Now, boron, if you see, so this is the element, this table if you refer, so how much abundance it has, in which mineral it is formed, and in which place of India do we get this elements. Okay. Now, boron generally shows how many isotopic form? Two isotopic form. Boron 10 and boron 11. And boron 11 is the abundant one. How much it is? 81%. Is that clear? And boron is a very rare element in Earth crust. So you can see how much it is. It is 0.001% by mass. It is even less than that. So it's a fairly rare element. Okay. And the mineral from which we can obtain boron element is orthoboric acid. See, just look at this. Okay. Orthoboric acid is there. Okay. Then we have borax. What do we have? We have borax. And then we have this ore, kernite ore. Okay. So if you see, these are the minerals from which we are going to obtain boron element. Okay. And where do we get all of this? So boron generally occurs in this part of India, the Puga Valley in Ladakh and Sambar Lake of Rajasthan. Okay. Now what about aluminum? So aluminum, if you see, it is the most abundant metal. Okay. There is no metal. which is as abundant as aluminum. And hence, if you see, aluminum is very cheap in market compared to other metals. Is that clear? And not just it is the most abundant metal, as well as it is the third most abundant element in the Earth's crust. Third most abundant element in the Earth's crust, followed by what? Oxygen and silicon. So oxygen is the most abundant element. After that, silicon is there, and the third most abundant element is aluminum. Is that clear? What is the like mass percentage by mass of aluminum that exists? So it is 8.3% by mass. Okay. And very famous ore, bauxite, from which we can extract aluminum. Okay. You would have studied this, right? One mark question in your childhood. And cryolite is also one of the ore or mineral from which we can extract aluminum. And where do we get these minerals? So we find they are found as mica in Madhya Pradesh, Karnataka, Odisha, and Jammu. So these are the region in which, okay, like if you don't remember the region, it's fine, but you remember from which mineral we are going to abstract these elements. Okay. Now, electronic configuration. So throughout the family, if I talk about boron family, for the whole family, the outermost electronic configuration will be same. Okay. So N represents the outermost shell. What does the N represents? The N represents the outermost shell. Because boron belongs to second period, so the electronic configuration is outermost electronic configuration is 2s to 2p1. Aluminium belongs to third shell, so the outermost electronic configuration is 3s to 3p1. Gallium belongs to fourth period, so the outermost electronic configuration is 4s to 4p1, and so on. Is that clear? So if you move down the group, the size will increase. No, if you move down the group, what will happen? The size will increase, and the new shells will be added. As a result, from 2, 3, and 4, you are moving over 5, then 6, then 7. Is that clear to everyone? Now, this difference in linear structure of inner core affects the properties and consequently the chemistry of all the elements of this group. Now, we'll study what do we mean by inner core. Okay, we'll come to that point. So, this is the general electronic configuration of boron family. What is it? NS2 NP1. And these are all the elements listed. We don't study this element. Okay, why? Because it is radioactive in nature. So, we are only going to study till helium. Now, coming to the atomic radii part. So we all know that moving down the group, what happens? Atomic size increases, right? It's all. So if you move down the group, what happens? Atomic size increases. So what is expected? It's not visible. So expected was what was the expected, right? As we move down the group, so atomic radius should increase. No. So boron will be least, then aluminum, then gallium, then indium, and the least will be sorry, highest will be thallium, right? This is what we are expecting. But what is the exception? You can see the exception is what? That radius of gallium, atomic radius of gallium is less than that of aluminum. So actual trend is something else only. Is that clear? What is the actual trend? The actual trend says that aluminum is what? What about aluminum? It is higher in size compared to gallium. Why? The reason is written over there. What is the reason? Have you heard of contractions? Tell me. Have you heard of contractions? Poor shielding effect. Periodic properties. Tell me. Anyone? No one has heard of that. Yes, tell me. Hmm?
Sir, we heard of lanthanoid contraction.
Lanthanoid
So
contraction. Very good.
that
Ah,
jet effective less in gallium.
see what happens. See, the reason is written over here. Okay, just a minute. Let me go to laser. Yeah. So if you see, as the d orbitals are larger in size as compared to s and p orbitals, their electrons do not shield the nucleus effectively. Is that clear? Now, in gallium, if you see, before gallium, all the d block elements come, right? If you see the electronic configuration of gallium, before gallium, all the d block elements come. The science teacher, very cool, man, scandium, titanium, vanadium, chromium, all this comes. No. So after zinc, we have this gallium. Gallium is 31. No. So it comes after zinc. So before that, we have d block elements. Now, d block element, the electrons are present in d orbitals. And d orbitals are poor shielders. What do we mean by poor shielders? So they don't shield the outermost electron effectively. Have you heard of shielding effect? So the inner electrons, what do? They take the most nuclear charge. So the outermost electron does not get that much of nuclear charge. Are you getting my point? As a result, it's not that much attracted towards the nucleus. But in case of gallium, what happens? Because before gallium, we have all the d block elements. So the d orbitals are filled with electrons. As a result, what will happen? The electrons which are present in d orbitals, they are not good shielders. It means because of their large size, they are not able to take the maximum nuclear charge. As a result, whatever nuclear charge is there, it will go to the outermost shell of the SNP. Are you getting my point? Because of that, what happens? The outermost shell electrons, they are very much attracted towards nucleus. Why? Because the inner electron, the d orbitals which were present inside, they are poor shielders. They are not able to shield the outermost electron properly from the nuclear charge. As a result, the nuclear charge will reach the outermost electron. And when it reaches the outermost electron, that is S and P orbitals, what will happen? They will be attracted towards nucleus. And as a result, the size will shrink. Is that clear? So hence in gallium, the force of attraction between the valence shell electrons and the nucleus is larger. Why is it larger? Why the force here is larger in gallium? Because gallium, before gallium, we have d block elements and it has d orbitals. The electrons in d orbitals, they are poor shielders. They are not able to shield the outermost electron properly. As a result, what happens? The nuclear charge will reach effectively on the outermost electron, resulting in shrinking of the size. As a result, you have to remember this exception that we were expecting this trend, but actually it is what? So it will go up. So boron is less, then aluminum will be more. But after that, what will happen? We were expecting aluminum se zyada gallium, but gallium became less than aluminum. But again, after that, it increases. Can you see that? See, from boron 88 to 143 picometer. From 143, it was expected that it will be more for gallium, but actually it is less. Why is it less? Because of what? Decontraction. Is that clear? D means what do we call it? क्या है ये? All these are what? Tell me. D block contraction बोलते हैं इसको. What do we call it? We call it D block contraction. Okay. You would have heard of lengthenoid contraction, right? Lengthenoid contraction. Similarly, gallium undergoes transition contraction. This is D block contraction. Are you getting my point? Can you proceed? Have you understood this or no? Wait, let me. Are you guys there? Hmm. Yeah. Okay. ठीक है. चलो. Moving on. Yes. Now, coming to ionization energy. Coming to what? Ionization energy. Do you remember the definition of ionization energy? The minimum energy required to remove an electron from the outermost shell of an isolated gaseous atom. Do you remember the definition of ionization enthalpy? Tell me. Yes or no? Now, if you remember that ionization energy is inversely proportional to size. Is what? It is inversely proportional to size. Got it? And directly proportional to Z effective. Actually, Z effective is the dominant factor. Then we go for size. Are you aware of this? Tell me. So this is the trend of ionization energy for boron family. But why? Why is it like that? Because just now we studied these two factors. No. See what happens. You all know this atomic radii trend. So boron is the one which has the least atomic radii. So it has the highest ionization enthalpy. Can you see that? Why? Because ionization energy is inversely proportional to size. Is that clear? So boron will have least. But by that logic, if we go by size, then again we know that boron, then after that Which size is there? Gallium is there, no? So gallium, then aluminum, then indium, then thallium. This should be the expected order because just now we studied that gallium size is less compared to aluminum. So if the size is less, then ionization energy will be more. If that is the case, then why we have seen so gallium is there, aluminum is there, indium is there, but thallium all of a sudden it increases. Why the ionization energy for thallium is increased all of a sudden? There should be some logic to that. And what is that logic? Your lanthanoid contraction. What is that logic? Tell me, what
Sir,
is that logic? Logic
sir,
is
sir, slide is not updated.
sorry,
The slide is not updated.
slide is not updated
Still on atomic radar.
for everyone.
Yes.
Yes, sir.
Yes.
Yes.
Yes, sir.
Oh, just a minute. Updated now. Updated or not? Tell me.
Yes.
Uh, is it moving?
Yes.
Yes.
It's okay. Smooth. Huh. So, from boron to aluminum, we know, like just now we saw that aluminum and gallium, there is this difference in size. And why is it? It is because of this D block contraction, right? Just now we studied that. So, decrease from boron to aluminum and gallium to indium is due to increase in size. If the point is valid, we're expecting this one. We are expecting this order, right? But are we getting that order? No, we are getting some random order. What is this order? We are getting that boron is highest. Then all of a sudden, we are expecting gallium, aluminum, indium. But thallium comes all of a sudden. Why? Why? The reason is lanthanoid contraction. What is the reason? The reason for thallium to undergo this much ionization enthalpy is what? Lanthanoid contraction. Now, what happens? See, the increase from indium to thallium is due to low screening of inner F electrons. So, in lanthanide, what happens? So when lanthanide arrives, they have electrons in f orbitals, yes or no? And the shielding effect. What is the order? The best shielders are S, then comes P, then D and F. D and F are considered very poor shielders. F is the poorest of all. Is that clear? Therefore, if shielding effect is poor, what happens? The outermost electron will be heavily attracted towards nucleus. Yes or no? Its Z effective will be more. So can I write ki because of poor just a minute. Yeah. Because of because so because of poor shielding, outermost electrons Z effective increases. Is that clear? The outermost electron, their nuclear charge will increase. No. Why? Because the inner electrons, they are not able to capitalize the nuclear charge coming to them. As a result, what will happen? The outermost electron will receive the nuclear charge. And when they receive that extra nuclear charge, additional nuclear charge, in other cases, which was not coming, but in case of poor shielding effect, it is coming. As a result, they will be highly attracted toward nucleus, their Z effective will increase. And when Z effective will increase, what will happen? Ionization, the enthalpy will increase drastically. Is that clear? So please remember this exception of ionization enthalpy for boron family. Okay, we are expecting this. This was expected, but the actual is this. So thallium, all of a sudden it increases. It becomes more than gallium, aluminum, and indium, but less than boron. Okay. Now, okay. Have you heard of inert pair effect? See, this is all the application part till now. Like in the first class, like throughout the class today, you will see that we are going to discuss the part, like some of the part which we have already discussed in chemical bonding and periodic properties. Okay. So I'm assuming that inert pair effect everyone knows because this would have been discussed in periodic property. If not known, let it be no issue. But like this is just an assumption that it is discussed in periodic properties. Now, because of inert pair effect, what happens? So you would know that the lower element, the elements which are present like bottom of the periodic table, so they show variable oxidation state. Variable. What do I mean by variable? So, like the let's say for boron family, what is the outermost electronic configuration? NS2 NP1. Yes or no? For boron family, the outermost electronic configuration is what? NS2 NP1. So just now we saw that how to find out the maximum oxidation state. Take out all the valence electrons. So generally this element will stay as generally this element will stay in which oxidation state? Plus 3. So therefore, if you see boron here, it is observed in plus 3. Aluminum is also observed in plus 3 only, but very rare in plus 1. But gallium, indium, and thallium, they show plus 1 and plus 3. Is that clear? Now, why is it like that? So in inert pair effect, what happens? If you see, it's written over here. Again, same. The inner electron, the outermost electrons, they are not, like they will receive good amount of effective nuclear charge from the nucleus. Why? Because of poor shielding by d and f orbitals. Because of poor shielding by d and f orbitals. As a result, what happens? The s, because just now we studied, no, here we just now we studied that shielding effect order is what? S is the best shielder. So the electrons of s orbital will be best shielded by the nucleus. Now, therefore, what happens if we move down the group? What is written over here? Let me use the laser. So when we move down the group, due to poor shielding of intervening d and f orbitals, very important point. So in gallium, it is d orbitals. In case of thallium, it is indium and thallium, it will be f orbitals. Is that clear? So moving down the group due to poor shielding effect of intervening d and f orbitals, the increased effective nuclear charge holds ns electrons tightly. And if ns electrons are held tightly, will they be donated? The answer is no. If ns electrons are held tightly, will they be donated? The answer is no. And thereby restricting their participation in bonding. As a result of this, only p orbital electron may be involved in bonding. As a result of this, only p orbital electron will be involved in bonding. Basically, what you have to remember is, so when we move down the group in a period, okay, sorry, in a periodic table, when we move down the group in a periodic table, what will happen? The thing is, the lower oxidation state, in case of plus 1, plus 3, what is the lower oxidation state? Plus 1, no. So the lower oxidation state will be the one which will be seen more often. Is that clear? Therefore, for thallium, plus 1 state is more stable than plus 3 state. Are you getting my point? For thallium, plus 1 state is more stable than plus 3 state. And not just for thallium, for all other groups. For carbon family, what is the lowest one? For PB, right? Plumbum. Okay, Shivji, Suno, Parvati. Do you remember carbon family? Carbon, silicon, germanium, SN, PB, stannous, stannic. क्या बोलते हैं स्टैनिन actually SN is what stannine and PB is plumber. SNPB. What will happen because of that? So if you move down the group for PB, plus 2 and plus 4, both the oxidation state will be seen. But which one will be the which one will be seen more often? The lower oxidation state. That is plus 2. Why? What is the reason? The reason is inert pair effect. What is the reason? The reason is what? Inert pair effect. Therefore, there is this very famous question in like PYQ. I hope you would have seen it. I'm assuming. Have you heard of this compound? TLI3. Hmm? So you will feel that here TL is in plus 3, plus 3I minus. If you think this is, then your assumption is wrong. Because TL, just now we studied, no, thallium, boron, aluminum, gallium, indium thalate, it is the lowest in the boron family. So which state will be stable, plus 3 or plus 1? Tell me. For
Plus
thallium,
one.
lower oxidation,
Plus
plus
one.
1. Therefore, TLI3 exists as TL plus I3 minus. Is that clear? This is very famous question of JEE mains. पूछा है, it has been asked in PYQs. So TLI3, it does not exist as TL plus 3 and 3I minus because TL plus 1 is more stable than TL plus 3. Therefore, Ti3 exists, Tl plus and I3 matters. Is that clear to everyone? Moving on. Now, the relative stability of plus one oxidation state progressively increases for heavier elements. So, what do we mean by this? If we move down the group, the lower oxidation state will become more dominant. Is that clear? Therefore, it is most dominant for thallium if you compare to indium, gallium, and aluminum. So, in thallium, plus one oxidation state is predominant, whereas the plus two oxidation state is highly oxidizing in character. Obviously, we know that if the charge is more, positive charge is more, so they can take electron, and if they take electron, so they are reducing themselves and oxidizing others. Is that clear? Hence, we say that higher oxidation state will result in high oxidation character. Okay. Now, the compound in plus one oxidation state are more ionic than those in plus three oxidation state. This is a very important point. Why? Now, acha, is very last point. Due to small size of boron, the sum of its first three ionization enthalpy is very high. This prevents it to form plus three ions and forces it to form only covalent compounds. This is also one thing. Because the size of boron is so small that it becomes very difficult for boron to release more than one electron. First of all, it won't even release it. It's very difficult to release one electron as well. But it can still release one electron. But to assume or to imagine boron is plus three state, so it has to release three electrons. No, which is not possible for boron. Why? Because the size is very small, and successive ionization enthalpy increase is very high. Like the successive ionization enthalpies are very high. So therefore, if you go for plus two state and plus three state, then it becomes very difficult to remove the electron from boron. As a result, what can happen? Tell me. So in case of boron, it won't show plus three state. It will only show plus one state. Sorry, क्या बोल रहा हूँ? हाँ, it will only show plus one state. Are you getting my point? Basically, if like assumption is what? Ki, uh, outermost electron is three now, so we can remove all three electrons from boron. But for boron, be careful that we can't remove all three electrons. Why? The reason is written over here. What is the reason? Yes, what is the reason for boron? Why can't it show plus three state? Because it has very small size, and as a result, the successive ionization enthalpy will increase very highly. The successive ionization enthalpy will increase very highly. Is that clear? Understood or not? Tell me. Can you proceed?
Understood. Yes.
Yeah. Now, one more thing. See, this for boron family, electronegativity trend is very interesting. Now, what is the general trend of electronegativity? Tell me. Like, how do you relate electronegativity? So, what is your observation for electronegativity? So, moving down the group, what happens generally? Electronegativity decreases, no? Because metallic character increases, yes or no? Tell me. This is what we have seen. This is what we have observed. Yes or no?
Sir.
So, but in boron family, this is not the trend. Can you see the trend? What do you observe from this trend? Give me the conclusion. Tell me.
Sir, boron desperately needs that electron for stability.
Boron desperately needs that electron for stability. No, but boron is the least, boron is the most electronegative of all. Anyway, fine. But what about, so down the group, if you see, you can see that first it is, the first electronegativity is decreasing. So from boron, the electronegativity value is 2. Aluminum is 1.5. Then it is increasing all of a sudden. Can you see this? Hmm? First it decreases and then it increases. But the increase is very slow or the increase is very less. You see that? So electronegativity first decreases from boron to aluminum. So from boron to aluminum if we come, the electronegativity value is decreasing. But from aluminum onwards, it is increasing slowly. And what is the reason behind that? The reason is the discrepancy in the atomic size of the element. Because we have seen now that aluminum gallium size difference is there, Indian thallium size difference is there. As a result, what happens? The electronegativity value gets influenced. Okay. So just remember that for boron family, there is this trend. Otherwise, for other family, the trend is not vague. Okay, it's like it's proper. So if we move down the group, we all know metallic character will increase, so electronegativity will decrease. But in case of boron family, first it decreases, then it increases slightly. So please remember this exceptional case of electronegativity in boron family. Okay. Now, okay. So if you see the boron family, it has boron, aluminum, gallium, indium, thallium. Now, now NCRT consider borons as non-metal nowadays. Initially, boron was considered as metalloids. Like even in some books, boron is considered as metalloid. Okay. But you have to go according to NCRT. NCRT says boron is non-metal. So we also say boron is non-metal. Okay. And gallium, aluminum, gallium, indium, thallium, they are categorized as metals. They are categorized as metals. Okay. So we all know that if you move down the group, what happens? Metallic character increases. In non-metallic character will decrease. Now, okay. Question came. Gallium has similar covalent radii as aluminum because of the atomic rate is almost same. Why? What is the reason behind that? Which option is correct? Yes. Which option is correct? I mean, is the slide visible to everyone? Is it moving or not?
Yes, sir.
Hmm? Yeah. What could be the reason? Just now we studied, no, some time ago. That what happens in case of aluminum and gallium? Gallium, just before gallium, we have D block elements. What do we have? We have D block elements and shielding effect. Just now we studied, no. Tell me yes or no. What could be the option from this?
C.
Option C. Because d electrons of gallium, they are poorly shielded. They are what? Poorly shielded. As a result, what will happen? The outermost electron, they will receive high nuclear charge. When they receive high nuclear charge, the size will decrease compared to aluminum. Is that clear? Have the same covalent area because of poor shielding power of d electrons of gallium atoms. Is that clear? देखो ऑलमोस्ट सेम है एटॉमिक रेडिया यहाँ पर डेटा तो थोड़ा इसमें इसमें 122 दे रखा है बट ठीक है इतना ज्यादा नहीं होगा गैलियम का या
Sir,
गैलियम
in the
shows
previous
different
slide, sir, it said that metallic character increases down the group, right? But we had said
yeah
that electronegativity also increases down the group. So isn't electronegativity linked to non-metallic character?
no, electronegativity decreases increases नहीं decreases
So from aluminum
I
to
said
thallium,
हाँ हाँ मैं वही तो बोल रहा हूँ see what I said in case of boron family you will see this exception generally what happens is if you move down the group metallic character will increase no so electronegativity will decrease are you getting my point but boron family what happens first it decreases then it slightly increases I told that boron family is the only family in which you have to
so sir, how
remember the
can that
trend of
correlate
electronegativity
with more metallic character? Because isn't it inversely proportional?
electronegativity and metallic character yeah inversely proportional only no
So how can both of them increase down the group? That's what.
no you are not understanding the point properly see what I said that for all the other groups, if you move down the group, what will happen? Metallic character will increase, yes or no?
Yes, sir.
And as a result, electronegativity will decrease. Understood?
Yes, sir.
But in case of boron family, that is not the trend. So initially it decreased, but after that it increased. And why? What is the reason behind that? The reason is in the discrepancy of the atomic size of the element. See,
Yes, sir. So
in
here
boron
both
family, in boron
electronegativity and metallic character will increase.
no, see, logic क्या है यहाँ पर? कि general trend, I told you, I don't think so you heard that point, that electronegativity का trend is like, you don't have to remember the trend for electronegativity in other groups. Only for boron family you have to remember. Why? Because there is this anomaly in this. Why? Because first of all, gallium shows some discrepancy compared to aluminum, and then thallium also shows some discrepancy compared to indium. As a result, the electronegativity trend is slightly different compared to other groups. Are you getting my point? But in other cases, what will happen? Down the group, metallic character will increase. No. So
Yes,
electronegativity
sir.
will
So it will
decrease.
decrease
Understood? But
electronegativity.
in this case, it is not the same.
Yes.
You understood the logic why? Because of
Yes.
discrepancy in the atomic size of the elements.
Sir,
Yeah.
why is
Can,
indium's
huh? Indium what? Tell me.
Sir, why is the indium's electronegativity greater than a gallium?
What?
Sir, because the size of indium is more than gallium, right?
Size of indium is more than gallium. Yes.
Sir, so
So,
like how is its electronegativity greater than indium?
first of all, ये जो भी यहाँ पे whatever this plot we have obtained, no, this is experimental plot, okay? Are you getting my point or not? Now
Yes.
coming to the point ki why indium is showing more electronegativity than this thing, अपना gallium. So if you see, then by that logic, अपना 1.6 है 1.7, this is gallium. So if you go by that logic, 1.6 gallium का उससे ज्यादा होना चाहिए था, but it is all experimental trend. If you see, अगर तुम size का देखोगे, so size इसका less, size is more, no, for indium compared to gallium. So by that logic, it should release that electron easily, no? Are you getting my point? Or its
Yes.
metallic character is also more compared to, yeah. But it was experimentally seen. See, the thing is what over here, it falls in between gallium and thallium, okay? Now here what will happen? Gallium will show D block contraction. Is that clear?
Yes.
Gallium is showing which contraction? D block contraction. And in case of thallium, it is showing F block, the lengthened contraction. So because of this contraction, it was like it is a resultant experimental effect that indium has slightly. If you see, not like drastically, it is not more. It is very slightly more compared to gallium.
Ah, yes.
Is that clear? But logic, if you go, then yeah, it should not be like that. But it is experimental trend, so you have to remember that. Therefore, the point is like that. First, it decreases, then it slightly increases. Can you see this? Electronegativity first decreases from boron to aluminum and then increases marginally. Now, this abnormality will be there because it is present between these two elements, gallium and thallium. Gallium is undergoing which contraction? D block contraction. This is undergoing lanthanide contraction. So, because of that, this abnormality is seen. Understood?
Yes.
Okay. Yeah. Thallium shows different oxidation state as compared to its group elements. The reason is, does it show different aluminum oxidation state compared to its group element? Does thallium shows different oxidation state compared to its group elements? Fast. If yes, then what? What is the reason? Achha, thallium falls in which comes in which family? Boron family. Boron, boron, aluminum, gallium, indium, thallium. What is the outermost electronic configuration for boron family? NS2, NP1, yes or no? So it can show +1 and +3 oxidation state, but down the group, lower oxidation states are more stable or more predominant, yes or no? So thallium will show which oxidation state, +1 or +3? Thallium will show which oxidation state, +1 or +3? Yes,
+1.
+1.
+1. Why? What is the reason? The reason is, what is the reason? The reason is inert pair effect. What is the reason? The reason is what? Inert pair effect. See what happens? So because of inert pair effect, what happens? The NS electrons are heavily attracted. They are what? They are heavily attracted towards nucleus. And as a result, hence, hence, it is difficult to donate. Therefore, thallium loses only p electrons. Understood? Therefore, +1 oxidation state is got it or not? And the reason lies in inert pair effect. The reason lies in what? Inert pair effect. Can you proceed? Tell me. Which ion does not exist in the compounds?
D.
Option? Which option?
D.
Sir, A.
B. Someone
Oh,
said B.
oh, A.
Sir, option A,
A,
boron
no.
data.
Yeah, and why? What is the reason behind that? Because size of boron is so small that successive ionization cannot be taking place. Why? Because of small size, very high amount of ionization enthalpy will be required. As it is better to not remove more than one electron. Is that clear? Okay. So it will only form covalent compounds. Now, ionization enthalpy of the elements of group 13 follows the order. So we have seen what should be the order for ionization enthalpy. Yes, what should be the order for ionization enthalpy? Tell me. Do you remember the order? Boron was the least or most. What it was? Most, no.
Most.
Yes.
Just how we studied. Ionization enthalpy is inversely proportional to size and directly proportional to Z effective. So if that is the case, then boron. Okay. After boron, what should be there?
Thallium.
Thallium.
It should be thallium. बोरॉन क्या thallium होना चाहिए. But if you see, the order is little bit different here. If you see the sign, if you see, can you see here? This is something like this. It is showing that. Can you see something like this? What does this mean? Hmm? There you go. This will be the correct option. Option D. According to me. See, what does it mean? It means that boron is highest. Okay. Then after that we had, can you see? And then what does this data show? It shows that aluminium is less than gallium. Okay. Can you see this or not? And gallium is more than indium. But thallium is more than all of them. Are you getting my point? What does it mean? It means that boron is the highest. Then after that, we say boron is highest. Then we say that aluminium has less than gallium and gallium has more than indium. Is that clear? And aluminium, gallium, indium, all of them are less than thallium. The trend that we studied was boron, thallium, then it was gallium, then aluminium, and then indium. No, this is what we studied, right? So if you read, it should be like that only. Boron is the most, then after that, thallium, then comes your aluminium, sorry, gallium, then aluminium, and then indium. Are you able to read? What does it mean? See. So correct option should be option D. D is only. See, can you read this? Laser. Let me use the laser. Are you able to read this? Huh? So boron is highest. Then it says that gallium is higher than aluminium and indium both. And if you compare to aluminium, gallium, and indium, thallium is the highest. Like thallium has more than all of them. Understood? Boron is highest among all. Then comes thallium. Then it is gallium. Then aluminium. Then indium. Okay. So therefore option D is correct. And these are the experimental ionization enthalpy values in kilojoule per mole it is given. Okay. Can you see that? It's matching with the data. Yeah. Most stable compound in +1 oxidation state is formed by. Which one will have the most stable compound in +1 oxidation state among this? Then,
A
huh?
option.
Boron.
Option A, sir.
Sure, boron. +1 means what? It is losing electron. No. So
Yep.
it means it is forming something ionic. Boron won't form ionic. Boron will form covalent bond. No. Are you getting my point? Boron won't like to lose
How is it
electron only.
going?
It will form. It should be D option. Which option it should be? Tell me. It should be D option, no? Thallium. +1 oxidation state, lower oxidation state, no? Inert pair effect. What is this effect called as? Inert pair effect. General oxidation state shown by group 13 elements are, generally what do they show? NS2 NP1, no. So either
A,
they can release all three electrons, or they will only lose the p shell electron, a p subshell electron. Okay, so option A will be correct. Now, okay, so physical property of melting point, boiling point, density. Let me just check what else is there. Then we have to discuss about specific. Okay. Okay. ठीक. Yeah. So, see, for boron, okay, see, boron is a non-metal. Okay, what is boron? Boron is a non-metal, and its boiling point and melting point, both of them are very high for boron. Okay. Now, if you see, then melting point of aluminum is 933 Kelvin. For gallium, it is 303 Kelvin. Acha, gallium, you would have heard of gallium. If you take gallium like in a tube, in a palm, so in the tube it will be solid only. But if you take that tube in your palm, then gallium melts because of this very low melting point. How much melting point? It is 303 Kelvin. Okay. So now what is the reason given? So decreases up to gallium and then increases up to thallium. Why? Due to very strong crystalline lattice. Boron has unusually high melting point. Gallium could exist only in liquid state during summer. Now the thing about gallium, I told you that the melting point is very less. So if you take it in your, like, if you take that metal in the tube and take the gallium in your hand, in that tube in your hand, then from your palm temperature it melts usually. Okay. And so just remember the trend. Then what does it show? That from boron to gallium it decreases, then from gallium to thallium again it will increase. Is that clear? So decrease up to gallium and then increase up to thallium. What is the reason? The reason is strong crystalline lattice. Now, this lattice and all, you are not aware, right? Because this is a part of solid state chemistry. Solid state is deleted. We'll see whether we'll cover that or not. Okay. But the thing is, if you have crystalline structure, then crystalline structure will give you high melting points. Okay. Now coming to boiling point. So boiling point of boron is very high. अच्छा, boiling point of boron is very high. Therefore, it has very extensive uses. अभी हम लोग पढ़ेंगे boron का use. Okay. So मैं बताऊंगा आगे boron का. Like what generally we'll use boron. Have you heard of pyrometer? Has anyone heard of pyrometer? I just want to know. Has anyone heard of pyrometer? Pyrometer. No? No one? No issues. Sure. We'll discuss it along with this. We'll discuss it later. See, so boiling point of boron is the highest among all. Then comes aluminum, then gallium, then indium, and then thallium. So over a period of time, if you decrease, like if you move down the group, what is happening? Boiling point is decreasing. Why? Due to large difference between boiling point of melting point and boiling, it is a useful method for measuring high temperatures. अच्छा, गैलियम का यहाँ, हाँ, गैलियम है, और ये गैलियम का melting point is what? 303 Kelvin and boiling point is 2676 Kelvin. I was talking about pyrometer, no, now. So you realize that we use gallium in pyrometer. Okay, what do we use? We use gallium in pyrometer. Why? Because of this only. So the wide range of temperature that it provides us, the melting point is 303 Kelvin and the boiling point is 2676 Kelvin. Is that clear? So between this temperature, it is liquid only, no? So during this such a huge temperature, so above 303 and below 2676, what is it? It is liquid in nature. So therefore, gallium is used in pyrometer. Okay. Thermometer, देखा ना, thermometer. You have seen thermometer, right? Yes or no? Thermometer, which liquid is there? Do you know? Inside thermometer, what do we have? Can
Mercury.
anyone tell me? Mercury. Similarly, in pyrometer, when we have to measure very high temperature, 1000 degrees, like that, 1300 degree, 1400 degree. In such case, we use pyrometer. Got it? So in pyrometer, the liquid that we have is gallium. Okay. And density, density, if you see what is happening over to density. So when we are moving down, the density of helium increases down the group from boron to thallium. So moving down the group, density and boiling point will, density will increase and boiling point will decrease. Is that clear? But melting point may, first what will happen? It will decrease till gallium and then increase up to thallium. So this physical property, please remember. What about this boron? Boron is a non-metallic in nature. It is extremely hard and black colored solid. Exists in many allotropic form. Boron has unusually high melting point. It has very high melting point. It is a non-metal in nature and very hard. The color of boron is what? Black solid. But other than this, what I'll add over here is that boron के both the forms exist. Boron exists in both the form. Okay. Crystalline as well as, so please note this extra one part. Crystalline as well as amorphous part. Crystalline as well as amorphous part. Okay. Crystalline part is less reactive and amorphous part is more reactive. Got it? Crystalline part is less reactive and amorphous form is more reactive. Is that clear to everyone? So these are allotrope, like it shows allotropy. Boron will show allotropy. Okay. So you have to remember this. And rest of the members are soft metal with low melting point and high electrical conductivity. Okay. But for boron, you remember this, okay? Not only boron, even thallium also shows allotropy. What about aluminum, gallium, and indium? They don't show. Okay, they don't show allotropy. Can you proceed? The element which exists in liquid state for a wide range of temperature and can be used for measuring high temperature is, just now I told you, we're discussing
C.
about pyrometer. Option C. Is that clear? Because it exists in such a wide range in liquid form that it can be used to measure very high temperature, and therefore the device that we are talking about is pyrometer. Melting point is highest for. So, melting point का trend is studied. No, first it decreases till gallium and then it increases till thallium. Decreases means so highest will be for what? La? It will be highest for boron, no? Tell me. Just now we studied no melting point. See? What is written over there? Decreases up to gallium and then increases up to thallium. So from boron to gallium it will decrease, then again it will increase. Don't forget this line. Okay? Sorry. Again. Boron. Now on moving down the group, 13. Density, what happens? So density and boiling point have fixed trends. Moving down the group, boiling point decreases but density increases. Moving down the group, what happens? Boiling point decreases and density increases. Is that clear? You can see that experimental data of density. Now, chemical properties. Now, what are we going to study? We are going to study chemical properties. Okay? Just a minute. Chalo. So, what is written over here? So, और try highlights there. ठीक है चलेगा. What is that? Yeah. So, chemical properties of compounds in trivalent state. I said this valency you know or not? Are you aware of valency? So second period element can have maximum covalency of 4. Is that clear? Third period and onward have expanded octets, so they can have more than 4. But third period, sorry, second period element can have maximum covalency of how much? 4, okay. Okay, not more than that. They can't have more covalency than 4. I'm talking about which period? Second period. But third period and onwards, they have d orbitals, no? So they can have maximum, like more covalency than 4. Now, what is written over here? Laser. This laser. Laser. So, chemical properties of compound in trivalent state. So, in trivalent state, group 13 elements form electron deficient molecules. And you would have heard of BCl3, BF3, yes or no? You have heard of Lewis acids, right? So we are talking about Lewis acid only. To form electron deficient molecules which have tendency to accept pair of electrons to achieve a stable electronic configuration and thus behave as Lewis acid. Thus behave as what? Lewis acid. The tendency to behave as Lewis acid decreases with increase in the size down the group. So it means if you move from boron to aluminum, will aluminum act as Lewis acid? Yes, but the tendency will decrease compared to boron. Are you getting my point? Example, BCl3 easily accepts a lone pair of electron from ammonia. AlCl3 achieves stability by forming a dimer. AlCl3 is also a Lewis acid. It can also accept electron. But instead of accepting electron, it prefers to undergo dimerization. Can you see this? It prefers to undergo what? Dimerization. Got it? But in case of BCl3, it forms adduct. What does it form? It forms adduct. Have you heard of adduct formation? Are you aware of adduct formation? Anyone? Tell me. Have you heard of adduct formation or not? Hmm? No one has heard of adduct formation. Array, what is adduct? So when Lewis acid, yeah. So when Lewis acid reacts with Lewis base, we all know Lewis base has electron, lone pair or negative charge, and Lewis acids have. क्या होता है? Vacant or why is it not coming out? Okay. Lewis acid has vacant orbital, no? So this will go and donate electron over here. So the product that we get is Lewis acid and this coordinate bond, Lewis base. What does this denote? It denotes adduct formation. You can see BCl3 is here, no? So boron has vacant p orbital and nitrogen has lone pair. So lone pair will be donated in vacant orbital of boron. Okay, the compound resultant compound will be called as adduct. What is it called as? Adduct. So this is your adduct only, but it is not adduct. It is not written as adduct. Why? Because the bond is covalent, not coordinate covalent bond. Okay. So in adduct, always remember that the Lewis acid and Lewis base will be attached by a coordinate covalent bond. Okay. Now, in trivalent state, most of the compounds being covalent are hydrolyzed in water. They are what? Hydrolyzed in water. So, अच्छा, when we are talking about MCl3, here metals की बात हो रहा है. We are not talking about boron, okay? MCl3 on hydrolysis in water forms tetrahedral MOH4 minus species. And aluminum chloride in acidified aqueous solution forms octahedral. Acha, now again one more thing. So if you see, aluminum belongs to which period? Third period. Yes or no? Therefore, it can form 6 bonds here. Can you see that? Al is attached with how much? H2 molecules, 6 molecules. But this is not the case for second period element. Second period element can show maximum covalency of 4 only, no? Tell me, second period element can show maximum covalency of 4. As a result, can it have six ligands attached to it or 6 bonds attached to it? The answer is no. But aluminum can show that. Why? Because it is a third period element. It can show expanded octet. So it can form more than 4 bonds. It can have more covalency than 4. Understood? Just a minute. This hydrolysis wala point, let me write it over here. So I'll is it given over here? In trivalent state, most of the compounds will polar hydrolyzed in water. Okay. Yeah. So here, when we are talking about this metal is what? Aluminium and gallium only. Okay, and etc. Means aluminium, gallium, etc. Except boron. So here we are not talking about boron. Are we talking about boron? Tell me. Tell me yes or no. Are we talking about boron? The answer is no. Here we are only talking about the metals. When I'm saying that MCl3 on hydrolysis in water forms tetrahedral MOH4 minus species. So this, by this, what do I mean? I mean that I'm talking about aqueous solution of metals. Okay, not boron, except boron, except, except, it's lagging a little bit. Except boron. Is that clear to everyone? Tell me. So please remember that like boron will not undergo hydrolysis to form tetrahedral species. Is that clear or not? Acha, one more thing. Uh, BCl3. Yeah, BCl3, B, BBr3, then BI3. Okay. And you can also include BF3. All of them are what? Electron efficient species. No. But they do not form dimer. Do not form dimer. BCl3, BBr3, Bi3, BF3. All of them are electron deficient species, right? But they are not going to form dimer. Is that clear to everyone? Please remember this. Aluminum can undergo dimerization, but boron family can't undergo dimerization. Can you tell me why? Can you tell me why is it like that? Hmm? Why it can't undergo dimerization? Just now we saw here, no? Aluminum can undergo dimerization. See? AlCl3. So 1Cl, 2Cl, third Cl. This is aluminum. So AlCl3. Here also aluminum, then 1Cl, 2Cl, third Cl, Al3. Can you see this? Aluminum can undergo dimerization. Why not boron? I just want to know the reason.
Because of boron's small size.
Yeah, because boron has small size. So what will happen because of that? Steric repulsion will take place. So if it tries to undergo repulsion, if it try to undergo dimerization, then the side atom size are very high. No, chlorine, bromine, these are high in size, and boron has very small size. So because of that, what will happen? Steric repulsion will take place. Therefore, it won't undergo dimerization. Is that clear? The reason is what? Because of steric repulsion. Because of what? Steric repulsion.
So
Please remember this. Okay. Yeah.
then why does BH3 form that banana bond thing?
Banana bonding is different, no?
But like still, the structure looks similar.
No, no. So that is a three-centered two-electron bond, first of all. Banana bonding. We'll come to banana bond. Don't worry. Right? We have to study dibonding in that case. We'll see. But
So that time steric hindrance
in-
doesn't work. Means steric repulsion.
no, that does not exist. It does not exist because hydrogen is very small atom, no? Now, if you compare chlorine and hydrogen, which atom is bigger? Tell me. Obviously, chlorine.
Oh yeah, yes sir.
Understood. In that, hydrogen is very small size atom. So in that, steric repulsion won't take place. Is that clear? So banana bond can be formed easily. Can you proceed? So please remember this point, okay? That MCl3 on hydrolysis. So whenever we are talking about MCl3, actually that is not boron. That is anything but not boron in the family. Is that clear to everyone? Tell me. Can you proceed? Now, reactivity towards air. Reactivity towards air. In air, what do we have? We have oxygen and nitrogen. What do we have? We have oxygen and nitrogen, right? So, acha, these elements reacts with oxygen at moderate temperature to form oxides and with nitrogen at high temperature to form nitrites. So for nitrogen, the temperature required is high, and for oxygen, it is moderate. But in both the cases, generally you heat it. Okay. Boron is unreactive in crystalline form. However, amorphous boron are heating in air form B2O3. So this is very important point. And we have discussed also. Boron exists in two allotropic form, no, crystalline and amorphous. But crystalline form is less reactive and amorphous form is more reactive. So when we are talking about reactivity with air, which boron will undergo reaction? Crystalline boron or amorphous boron? The answer is amorphous boron. Understood? Yeah. Now, aluminum forms a very thin oxide layer on the surface which protects the metal from further attack. However, on heating in air, it can form Al2O3. Boron trioxide is acidic and reacts with basic oxides, forming metal borates. Aluminum and gallium oxides are amphoteric, and those of indium and thallium are basic in their properties. See, always remember that metal oxides, okay, non-metal, non-metal oxides. They are, what is the nature? What is the nature of non-metal oxides? Acidic or basic? Hmm?
Acidic.
They are, देखो इधर देखिए boron trioxide is acidic, so it means non-metal oxides are acidic. Okay, and metal oxides are basic. But please be careful that aluminum and gallium they will show amphoteric oxides. Aluminum and gallium will form which oxides? Amphoteric. Their oxides are what? Amphoteric in nature. What do we mean by amphoteric? They will show both. They will show both the characteristics of acidic as well as basic nature. Is that clear? So oxides will be formed for all the metals, for all the elements. B2O3 will be there. Okay. Then Al2O3 will be there. Then Ga2O3 will be there. Okay. This is acidic, but these two are amphoteric. Okay. And the last two are indium. So In2O3. And the last one is Tl2O3. These two are the last two are. If I ask you this two, what are they? Their nature is basic oxide. Their nature is what? They are basic oxides. Understood?
Sir,
Tell me.
sir,
Yeah.
but
Yes.
we said before that thallium will not have a +3.
See, it is stable in more stable in +1. ऐसा नहीं है कि वो बनाएगा ही नहीं +3. That is also the case. Okay. Generally, it forms which one? It is more stable in +1 state. Are you getting my point? But it is not at all. It does not mean that कि वो +3 में exist ही नहीं करेगा. Is that point clear?
Sir, so shouldn't
Yep.
it form Tl2O?
हाँ. Tl2O3 what?
So like
Tl2O what?
just
Continue.
Tl2O. That's all.
Tl2O. No.
Yes, sir.
No. It exists in Tl2O3 form. Thallium oxide exists. Okay. Is that clear or not? But again, when we are talking about acidic and basic nature of oxide, then we have to deal with that. See, for lower the elements which exist in the bottom of periodic table, okay, bottom in the group in the periodic table. What you have to remember is that for them, inert pair effect is very heavily uh, utilized. And what do you mean by inert pair effect? So, inert pair effect means that the lower oxidation state will be stable. But I'm telling you time and again, it does not mean that higher oxidation state will not exist only. Are you getting my point? ऐसा नहीं होगा that thallium will not show +3, it will only show +1. Is it clear or not?
Yes, sir.
So in case of Tl2O3, TL में +3 is there. But in case of TLI3, TL is +1. Is that clear? That thing you have to remember. And once you do these chapters, then you will come to know, okay, in which case +1, which example has TL in +1, which example has TL in +3. But good point that you raised here. Most of you would have assumed that TL won't show +3. It's not like that. Okay. Lower oxidation state will be predominant, but higher oxidation state will also exist for the elements which are present in the bottom of the group of the periodic table. Is that clear to everyone? So the conclusion is what? TL +3 and +1 both exist. Predominantly, which one exists? +1. Got it? Predominantly, which one exists? +1. Understood? Okay. Now, uh, reactivity towards acids and alkalis. See, boron does not react with acid and alkali. Alkali means what? Base. Alkali means what? Base. Is that clear? Even at moderate temperature. Even at moderate temperature. But I'll like to add one thing. ये तो अलग ही दे रखा है. Boron usually reacts. Okay, boron reacts. See, the thing is, what you can add for boron is boron does not react with oxidizing acids. Okay, so do not react with acid, but which acids? Oxidizing acids. Okay, sorry, non-oxidizing. It does not react with non-oxidizing acid. Now, what do I mean by non-oxidizing acid? Non-oxidizing acids. Example, HCl. So if you ask me, will boron react with HCl? The answer is no. Then water oxidizing acid, but it reacts with oxidizing acid. So what are oxidizing acids? So boron plus uh, concentrated HNO3. Okay, or boron plus concentrated H2SO4. So HNO3 and H2SO4 are oxidizing acid, no? So they will react with boron, and the product formed is H3BO3. Okay, what is the product from H3BO3? What is H3BO3? Do you know H3BO3? What is it? Yes. What is H3BO3? Boric acid, no? Hmm? Have you heard of H3BO3 or not? What is H3BO3? H3BO3 is boric acid. Acha, just an question. Where you have studied boric acid in chemistry? Which chapter? Anyone remembers? No one remembers. Ionic equilibrium you have not studied. Have you studied this in ionic equilibrium or not? Tell me. अरे बोल दो. You have studied or not? If you have not studied, fine, but I'm very much sure that you would have studied that. See, I need to ask one thing. What is the N factor for boric acid? Is what I need to ask. Can anyone tell me? This is a very famous example of ionic equilibrium. Acha, for H2SO, what is the N factor? Do you remember? Quickly, because we don't have that much time. 2. For HCl,
1.
1.
for HNO3, 1. For H3BO3, how much it is?
Like 1 or something.
1.
It's 1 only, no? Yes or no? And that too, it does not, no, it's not a protonic acid, it's a Lewis acid. Do you understand the difference? So we'll see that. We'll see that. H3BO3 will be formed, and if HNO3 is there, the side product will be NO2. And if it is reacting with H2SO4, then side product will be SO2 gas. Okay. Got it or not? Is it clear to everyone? So, if someone asks, does boron react with acid? The answer is yes. But which acids? Only oxidizing acids. Which acids? Only oxidizing acids. It does not react with non-oxidizing acids. Are you getting my point or not? So, if I say that whether it will react with HCl, the answer is no. But will it react with HNO3 or H2SO? The answer is yes. And what does it form? It forms boric acid. Okay. But aluminum, though, we all know it is amphoteric. No. So, aluminum dissolves in mineral acids and aqueous alkalis and thus shows amphoteric character. So it will react with acid and bases both. It will react with acid and bases both. Okay. Now aluminum dissolves in dilute HCl and liberates dihydrogen gas. That also we know. Okay. But when it reacts with aqueous alkali, again same thing will happen. What will it happen over here? So hydrogen gas will be released. Because the nature of element is what? Amphoteric, so it can react with acid as well as base both. And you can see in these two reactions. So here it is reacting with acid. Here it is reacting with base. Okay. Now the last point is important. So when aluminium and gallium, they are treated with nitric acid, concentrated nitric acid. Okay. Then what happens? So they render a passive layer, or you can say protective, passive, protective oxide layer on the surface. So this you have to remember that if you treat aluminum or gallium with what? With concentrated HNO3, then they will render a passive protective oxide film. They will render a passive protective oxide layer, oxide film, whatever you want to call it, okay, on their surface. Understood?
So can you go
Have you
back
noted this or no? Yeah,
the ones?
yeah. Done?
Yes.
Okay. Now, we saw that boron reacts with acid, but not all the acids, only oxidizing acid. But what about base? Will it react with base? Will it react with alkalis? The answer is yes. But please write down in the form of note that boron reacts with fused alkalis. Do you know what is fused? Fused. The word fused, what does it mean? Fused
Molten.
alkalis. Yeah, at a very high temperature. Fused alkali means what? At a very high temperature. So, acha, which base? Example. So it can react with NaOH or Na2CO3 along with NaNO3. Not coming up. What's taking for me? So it's lagging is there. Yeah. So this is called as fusing mixture. What do we call it? Fusion mixture. What do we call this, guys? We call this fusion mixture. So, boron can react with NaOH or it can react with Na2CO3 and NaNO3 ka mixture. What is that mixture called as? Na2CO3 and NaNO3 ka mixture is called as fusion mixture. Is that clear? And fuse temperature, what is the temperature here? Delta, like heat is how much? 900 degrees Celsius. How much heat is required? Almost of 900 degrees Celsius. Is that clear? Tell me. Now, what is the reaction? So, when boron will react with them, okay, boron plus NaOH. Or I write FM. FM means what? What does FM means here? Fusion mixture. What does FM mean, guys? FM here stands for what? Fusion mixture. It stands for what? Fusion mixture. So what is the product? We get Na3BO3. Na3BO3. Okay? 3 plus hydrogen gas is released and CO2 gas is also released. Along with this, which gas will also be released? CO2 gas. The CO2 gas also is. Very little space, so I have to write it like that. This is some additional point that you can note it down. So, does boron react with base? Yes, but in which condition? In fused condition. Will it react with aqueous solution of alkali? The answer is no. Is that clear? Boron can only react with alkalis provided the temperature is very high and the alkali is present in fused state. And that too with which alkalis? NaOH and fusion mixture. Fusion mixture consists of sodium carbonate and sodium nitrate. Is that clear to all? Please note this down. Can you proceed? Have you noted it? Yes. Has everyone noted this or not?
So 1 second.
Yeah. I'm not able to write here, but you can write it in the form of note that boron won't react with aqueous solution of alkali. Understood now?
What are the products?
Sorry?
What
Products
are the
for
products?
boron.
I know what are the
Na,
products that you
Na3BO3 plus H2 gas and CO2 gas is there.
So where does the CO2 CO2 is only in case of the fusion mixture, no? Not in case of any of which.
Sorry? In
So,
case of fusion mixture.
yes, sir.
But main product is Na3BO.
Yes.
Okay? And please don't forget to write the note that it won't react with aqueous solution. It won't react with aqueous solution of alkali. Then, can you proceed? Done or not, guys? Tell me.
Done, sir.
Okay. And aluminum, so the product formed is this. Along with that, we can also get this product, Na and then Al group. NaAl4. Okay. So either you will get NaAlOH4 or NaAlO2 in aqueous state. Both the products are formed in aqueous state. Please remember that. And I am assuming that everyone has written the note that boron does not react with aqueous solution of alkali. That is, boron plus aqueous NaOH will be no reaction. Okay. Chalo. Moving on. Reactivity towards halogen. So if you go by halogen, then what will happen? Yes, it reacts with halogen. And the reaction is already given to you. Okay, what does it form? It forms trihalide. Along with the exception that we have already discussed. What was the exception? The exception was TLI3. What was the exception? The exception was TLI3. Okay. Now, the trichlorides, bromides, and iodides of all these elements, being covalent in nature, are hydrolyzed in water. Species like tetrahedral, MOH4, and octahedral, MH2O6 plus 3, except in boron, exist in aqueous medium. This we have already discussed now. हाँ, during this slide, जब मैं यहाँ पे बता रहा था आप लोगों को, I was telling you, see, this MOH4, M is what? Aluminium, gallium, etc. But except boron. MCl3 on hydrolysis. Same slide is discussed over here. Same point is discussed over here. That the trichlorides which are there, the bromides, iodides, all these elements, boron, aluminum, gallium, indium, thallium. So they will react with water except boron. Aluminum, gallium, indium will react except for boron. Is that clear? This is what they have mentioned. The monomeric trihalides, being electron deficient, are strong Lewis acids. Now, what do you mean by monomeric trihalide? So, who does not undergo dimerization, that species will be called as monomer. And who does not undergo dimerization? Boron family, no. Who does not undergo dimerization? Boron family. So, the example BF3, BCl3, then BBr3, and then BI3. Okay. BI3. So this is what we are talking about. Please remember that except thallium, TLI3, okay? This we are whatever this trihalides are formed, this is except for TLI3 because in this trihalide, E is in plus 3, okay? So here it is E is in plus 3 and X is minus 1, like that. So be careful about it, okay? Yeah. Anomalous property of boron. It is due to the absence of d orbital that the maximum.
So
Yes,
can I go
somebody
back
is
on?
saying something. Yeah. Can you proceed?
So one sec.
Yeah. So in this slide, in the reactivity toward halogen, what we have seen is that all element of the boron family will react with halogen to form EX3. E stands for element. Okay. So whatever element it is, it will be combining with X3. But, but if you do the hydrolysis of these trihalides, then they will form tetrahedral species and octahedral species. But not for all the elements, except for boron. Boron won't form this tetrahedral and octahedral species. Okay.
Yes, sir.
So can we proceed now? So we know that maximum covalence of second period element is 4, which is what it is written over here. And what is the reason for that? Because they don't have d orbital available for that, right? So anomalous property of boron, what does it say? Due to the absence of d orbital, maximum covalence of boron is 4. Because d orbitals, since the d orbitals are available with aluminum and other elements, the maximum covalency can be expected beyond 4. Is that clear? Thus, boron halides do not dimerize like other elements which can form halogen-bridged molecules. Basically, it is trying to tell us that except for boron trihalides, all other trihalides can show dimerization. Then the logic why boron can't show dimerization? There are two reasons. First of all, its covalency is 4 only. It can't exceed 4, right? Maximum covalence of can be shown by boron can be 4 only. It can't exceed 4. Also, the size of boron is very less, and the size of the side atom like halogens, they are very large. So bridging becomes difficult. The dimerization property will become difficult. So these are few reasons why it won't undergo dimerization. Why boron family trihalides will not undergo dimerization. Is that clear? It comes under anomalous property of boron. Now what is written over here? A group 13 element X reacts with chlorine gas to produce a compound XCl3. XCl3 is an electron deficient and easily reacts with NH3 to form. Acha, can you see what is this? This arrow, if you see this coordinate arrow, what does it mean? Can anyone tell me what does this mean?
Add up.
Coordinate arrow means what? Adduct, no.
Adam.
Coordinate arrow means what? Coordinate bond. This is Lewis base and this is Lewis acid. So Lewis base gives electron to Lewis acid. This adduct formation. And where adduct formation will take place? Where electron deficiency is very high, where dimerization is not taking place? Yes or no? What should be the correct answer? Tell me.
A.
A. Very good. Why? Because boron trichloride can't undergo dimerization like other trichlorides. Is that clear? And as a result, to remove the deficiency, it will accept electron from a Lewis base, resulting in formation of adduct. Resulting in formation of what? Adduct. Sorted? No. No more explanation needed, right? Can you proceed? The correct statement among 1, 2, 3 regarding group 13 elements oxides are boron trioxide is acidic. Do you believe that? B2O3 is acidic. Do you believe it? I told you,
Yes, sir.
non-metal oxides are acidic in nature. So first statement is correct. First statement is correct. Okay. Trioxide of aluminum and gallium are amphoteric. That also we know that aluminum and gallium are amphoteric. They have amphoteric oxide. And indium and thallium oxides are basic. So it means all three statements are correct. Is there any option with all three statements? Tell me. Is there any option with all three statements? The option is B, which is all three statements correct, right? Yes or no? So non-metal oxides are acidic, metal oxides are basic, aluminum and gallium shows amphoteric oxide. They show amphoteric oxide. Which of the following cannot liberate hydrogen gas with acids? Now, who cannot liberate hydrogen gas with acids? Tell me.
Boron.
It's a boron.
Which one?
Boron.
Boron. Very good. Because metals, when they react with acid, hydrogen gas is liberated. Boron is a non-metal. So it won't release hydrogen gas. Acha, here we have written that boron does not react with acid and alkalis, even at moderate temperature. But we have seen it reacts, right? The PPT does not hold that much of point, but I have told you that boron reacts with acid and base both. But what is the product? Tell me. What is the product? When it reacts with acid, H3BO3 is formed, no? See, just now we did. When boron reacts with, ये रहा. Boron reacts with acid. What is formed? अरे यार, can you see this? कहाँ चला गया भाई? हाँ. Boron does not react. Like in this point only I mentioned, no? With concentrated HNO3 it will react. I have told that कि अपना HNO3 and H2SO are what? Oxidizing agent. So boron will react with oxidizing acid and not with non-oxidizing acid, right? HCl. So here we have seen that it reacts with acid, but it does not release hydrogen gas. Which gas is released? If it is nitric acid, then it will release NO2. If it is sulfuric acid, then it will release SO2 gas, along with H3BO3 as the main product. So hydrogen gas is not released by boron. Therefore, correct option here would be boron. Okay, guys. Moving on. Now, so this is first slide is over for us. I think I'm not wrong. This is just a summary of whatever we have done in the first PPT. So atomic radii, we know down the group, we expected that down the group size increases. But what we saw is gallium, sorry, gallium undergoes contraction, D block contraction, right? D contraction. What is it called as transition contraction? As a result, the size for gallium, what will happen to the size of gallium? It will decrease, yes or no? So therefore, boron followed by gallium, then aluminium, then indium, and then thallium. Is that clear? What about ionization energy? So for ionization energy, you have to remember that gallium shows transition contraction, thallium shows lanthanoid contraction. As a result, what will be the trend of ionization energy? Highest will be for boron, then it is for thallium. Then comes gallium, then comes aluminum, then comes indium. Okay. And I told you strictly that electronegativity order, that you don't have to remember electronegativity for any other series, but for boron family, you have to remember the electronegativity trend. Why? Because it has discrepancy due to atomic size variation. And in this family, atomic size variation takes place twice, in gallium as well as thallium. So because of that, electronegativity trend is affected. And what was the trend? So we say from, like, first what happens from boron to aluminum, it decreases and then slightly it starts to increase. So boron is more electronegative than aluminum, but aluminum is less than gallium, gallium is less than indium, and indium is less than thallium. Do you remember that plot? It was something like this. The tick mark plot was like this. Do you remember something a tick mark plot? Tell me. Yes or no? That's oxidation state. So for boron family, there are two oxidation states, +1 and +3. Both oxidation states are shown, but down the group for the element, the heavier elements, the lower oxidation state is more favorable. Why? Due to inert pair effect. Why? Due to inert pair effect. What about metallic character? So metallic character will increase down the group. Yes or no? Acha, melting point, boiling point density you have to remember. Melting point, mein what is the trend? Decreases up to gallium, then increases. But boiling point decreases down the group and density increases down the group. Please remember this trend. So this is the overall summary that we have done in today's class. Not just this, we have also seen some reaction. Okay. So if reactivity with air we have to check, then what happens? So we all know that boron and any other element in air, it reacts with oxygen and nitrogen. If it reacts with oxygen, it will form oxide. If it reacts with nitrogen, it will form nitride. Is that clear? There are two allotropic forms of boron, crystalline and amorphous. Crystalline is less reactive, amorphous is more reactive. Is that clear? Tell me. So crystalline boron unreactive, amorphous boron reacts because it is more reactive. And then what happened next? So aluminum forms oxide layer and does not react further. That also we have seen. Then what about acids and alkalis? Does boron react with acid and alkalis? The answer is yes. When it reacts with acid, which acid? Boron will react with which acid? Just now we discussed. Does it react with HCl? The answer is no. It only reacts with oxidizing acids like H2SO4 and HNO3. Okay. And what is the product that it forms? It forms H3BO3. Along with, if it is concentrated HNO3, then it will release NO2 gas. If it is H2SO4, then it will release SO2 gas. Is that clear? What about base? Does it react with base? The answer is boron does not react with aqueous solution of NaOH, but it reacts with fused alkali solution. What do we mean by fused alkali solution? It means at a very high temperature, temperature as high as 900 degrees Celsius. Do you remember that for boron? Tell me, bacho, yes or no? We have discussed this, no? Boron will react with
Yes, sir.
alkalis, but at a fused state at 900 degrees Celsius, around that temperature. Okay. And what do we get? We get Na3BO3 along with hydrogen gas. And if not NaOH, then we can also use fusion mixture. What was there in fusion mixture? Can anyone tell me? Na2CO3 and NaNO3 was fusion mixture. Do you remember that? Okay. Now, aluminum, because it is amphoteric, so it can react with acid as well as base both. When it reacts with acid, it will release hydrogen gas. When it reacts with base, in that case also it will release hydrogen gas. Is that clear? But this reaction of aluminum and gallium with nitric acid is very important. What is the reaction? They form a protective layer. What do they form? They form a passive protective layer, right? Do you remember this or not? That for aluminum and gallium, we have written that when they are treated with nitric acid, they develop a film on the surface. What do they develop? They develop a layer or film on the surface. Reactivity with halogen. So all the elements in the group 13, they will form trihalides. Boron will also form trihalide, aluminum will form trihalide, and so on. All the other elements will form trihalides. Is that clear? Just be careful, except triiodide of thallium, because generally when elements form trihalides, in that case, element is in +3. But in thallium triiodide, thallium is in +1. So this is exceptional case that you have to remember. Okay. Acha, one more thing. Reactivity with halogen we saw. In that also we also saw that hydrolysis of boron trihalides will not take place. Yes or no? But hydrolysis of other trihalides can take place and it can result in formation of tetrahedral complex or octahedral complexes. MOH4 minus, do you remember? Or MH26, do you remember that or not? So that
Yes.
reaction is possible, but not for boron. Can boron show those reaction? Hydrolysis of trihalides. Can boron's trihalide undergo hydrolysis? The answer is no. Is that clear? Tell me, understood or not? And then nature of trioxide. We all know that boron, like non-metal oxides are acidic, metal oxides are basic. Aluminum and gallium are also metal, but they show amphoteric nature. They can act as acid as well as base. Okay, that's it. That's the end of first PPT. Okay, guys. Any doubt, anyone? Or we can proceed with the second one. So I'll send this PPT. Okay, I'll share it in the. You'll receive it to class, but I'll send it to the respective person. They will send it to you guys. Okay. Do you want to ask anything, or we can proceed with all this? Whatever we need to do.
So
Tell
can
me.
we get a 5-minute break from that?
Break.
Yes, sir.
Hmm? Okay, join at 10 o'clock again. Okay, sorry.
Thank you, sir.
Thank you,
But
sir.
be sharp at 10 o'clock. Am I audible? Am I audible to everyone? We can start, right?
Yes, sir.
Okay. ठीक है. Let me share the screen. Yes, the screen is visible to everyone, right? Yeah. So now we'll move towards the second PPT. Total 4 PPT we have for the 13 and 14 group. Okay, first PPT is done. This is just a recap of whatever we have studied. Now, what are we going to study in the next class? Basically, in the upcoming class. So, compounds of boron. So, what are the important compounds of boron and aluminum that we have to study? Okay. Just a minute. Let me show it. Yeah. Okay. Yeah. So, uh, these 3 compounds of boron are very useful for us. What are these? Borax, orthoboric acid, and diborate. Borax, orthoboric acid, and diborate. Is that clear? So we'll study them one by one, and eventually we'll finish it all. So first we are going to deal with borax. Okay, borax. Now, what is borax? It is a white crystalline solid for of formula. It's like the form is what white crystalline solid, and the formula is Na2B4O7 dot 10H2. Okay. In fact, it contains the tetranuclear units of B4O5OH4 minus 2. And correct formula therefore is Na2B4O5OH4 dot 8H2. इसे अभी जो भी लिखा है नहीं समझ में आ रहा होगा ना. What is it? Just a minute. Then just look at this structure. What is this structure? This structure is for borax molecule only. This structure is for what? Borax molecule. And just be careful that there are total 4 boron atoms. Is that clear or not? There are total how many boron atoms? 4 boron atoms. Out of that, 2 are sp2. So this and this is sp2. This and this is sp3. Just count the number of sigma bond. 1, 2, 3, 4. Similarly, 1, 2, 3. Total 3 sigma bonds, so sp2. Here 4 sigma bonds, so sp3. Sorted? Now what is this? This is the structure of borax. This is the structure of borax. Is that clear? Now, okay. So what is written over here? Borax dissolves in water to give an alkaline solution. To give what? To give an alkaline solution. Okay. And if you see, this is borax. So when you have added it in water, what do you get? You get NaOH and boric acid, orthoboric acid. H3BO3 is what? Orthoboric acid. Or boric acid is also possible. So NaOH is a strong base and this is a weak acid. So they will react with each other. Yes or no? And when they react with each other, what do we get? We get acidic buffer. What do we get? We get acidic buffer. You would have seen this, that aqueous solution, in ionic equilibrium, you would have studied that aqueous solution of borax is buffer in nature. Like it's an example of buffer. Uh, so what is aqueous solution of buffer? Borax, this is aqueous solution of borax. So when borax is treated with water, what do we get? We get acidic buffer. Is that clear or not? And what is that process? So this is the process which it is showing over here. So in ionic, you would have studied clearly that aqueous solution of borax is called as is a buffer. It's an example of buffer solution. Why? And that too, it forms which buffer? Acidic buffer. Because when aqueous solution of borax is there, it results the overall final formation takes place of acidic buffer. And these are the species which are present after the complete reaction. Is that clear? So this reaction is in which case when it is treated with what? Tell me. This reaction is in which case when borax is treated with water, or you can say when we have taken aqueous solution of borax, we end up with acidic buffer solution. Is that clear? Now, acha, this is also very important. So, like, if you heat borax, first what will happen is water of crystallization will be gone. Can you see that? So on heating, only Na2B4O7 is there. When you heat this further, you end up with these two compounds. This is called as sodium metaborate, and this is boric anhydride. Okay, or it is boron oxide as well. So boron oxide or boric anhydride, whatever you want to call. Along with this, what do we have? Sodium metaborate. Now combined, they are called as borax bead. Have you heard of borax bead? Tell me. Have you heard of borax bead? Anyone? No one? Uh, have you heard of qualitative analysis, qualitative, quantitative analysis? No one has heard. ICSE students, CBSE. No one has heard.
So we've done qualitative analysis, but we didn't have borax bead tests.
Okay. But you will see that in 12th standard, you will see qualitative analysis. But actually, it also comes in subjective. Like qualitative and quantitative analysis is a subjective part as well for advanced people. Okay, so you will do that as well. At that time, you will see borax bead first. Okay, so borax bead is used for doing qualitative analysis. Is that clear? ठीक है ना? So, and how do we obtain borax bead? Just by heating borax. Just by heating borax. So first, when we heat borax, what do we end up with? We end up with Na2B4O7. So on heating, borax first loses water molecules and swells up. On further heating, it turns into transparent liquid which solidifies into glass-like material known as borax bead. And borax bead is a mixture of what? Sodium metaborate and boric anhydride. NaBO2 plus B2O3. Is it clear to everyone?
Sir, could you go to the previous slide once?
Which one?
Yes, sir. Once. Yes, sir. Done.
Okay. ठीक है. Now, देखो, how do we perform borax bead test?
So,
How do we perform
one
borax?
thing. Before that buffer solution slide, what was the?
This one.
Yes, 1 second. I just need that.
Yeah. This is the structure of borax.
Yes.
It has two sp2 boron and two sp3 borons atoms.
Yes. So, was there anything done before borax?
No, just we started with like
Okay.
what are the compounds of boron that we have to study in this chapter?
Yes.
There are these three compounds: borax, orthoboric acid or boric acid, and diboron.
Yes.
So we started with borax, and in borax, this is the introductory slide. What is the formula of borax? And then after that, we saw the structure of borax, in which this also is important. How many BOB bonds are there? Okay, so total 5 BOB bonds are there. There are 4 boron atoms, 2 boron atoms are sp3, and 2 boron atoms are sp2 hybridized. Okay. And then first, this is the thing. So, if you dissolve borax in water, we get an alkaline solution. Why? Because first it gives us this mixture, NaOH, which is strong base and orthoboric acid. So overall solution is what? Basic. Okay. Now, later on, what happens? So when they react with each other, they end up giving us acidic buffer. They end up giving us what? Acidic buffer. Is that clear? So therefore, in ionic equilibrium, I told at that time, if you have missed, that in ionic equilibrium, you would have studied that aqueous solution of borax is called as is an example of buffer solution. Aqueous solution of boron is an example of, sorry, aqueous solution of borax is an example of a buffer solution. That to which buffer? This buffer. Is that clear? And then we did borax bead ka formation. How do we get borax bead? So you don't have to do anything. You just need to heat borax and then you end up with Na2B4O7. The water of crystallization is lost. And when you heat that further, what do you end up with? You end up with sodium metaborate and boric anhydride, NaBO2 plus B2O3. Now, this combine is called as borax bead. Now, what is the use of borax bead? Borax bead is used for qualitative analysis. Borax bead is used for what? It is used for qualitative analysis. Now, where you are going to study qualitative analysis? In chemistry experiments. Okay, when you are going to do your lab and all. So, qualitative analysis is a topic in which you study cations and ions. Okay, at that time you require borax bead test. Now, how do we do borax bead test? It is written over here. It is discussed in this slide. So, borax powder is taken in a hot platinum wire loop and held in the hottest part of the flame. Can you see that? So, this is the platinum wire. Okay, and
So,
in this
sorry.
region
Can you
we
show
have the
previous slide 1 second? Yes, thank you. Done. Done, sir.
Okay. Yeah. So, how do we perform this test? So, you just need to take the compound which is under analysis on the platinum wire. Okay. So, borax powder is here. It's taken in a hot platinum wire loop, held in the hottest part of the flame. Can you see that? So, you have taken borax on the platinum wire and you have kept it in the flame. Now, what will happen because of that? So, when you heat borax powder, it loses water of crystallization. No. See, in this case, when we heat borax powder, what happens? It loses water of crystallization and we only end up with Na2B4O7. So the borax powder swells up due to the loss of water of crystallization and shrinks upon the loop, forming a transparent glassy bead, colorless glassy bead. Can you see in this? Now, hot bead is touched on the salt sample. Now, when you take this, and this is the, let's say the sample under analysis is your this sample. So when you get this, what do? You take it directly and touch it, and you make the contact of this part with this analysis sample. Is that clear? Now, hot bed. So this is hot bed is touched on the salt sample. So you have to take it and you have to like mix it. Like you just have to take some of the sample from this on this particular surface. Is that clear? And then you have to heat it again. And once you heat it, you observe the color of the bead and the color will change. What will happen? The color will change. Is that clear? Have you understood the process? How do we do borax bead test? So you take borax powder on the platinum wire. This is the platinum wire. Okay, this is glass rod in which platinum wire is kept. So this is the outsourced platinum wire. Now on this platinum wire, you have kept borax powder and then you heat that borax powder in the flame. So what happens when you heat borax powder? It loses water of crystallization and it becomes a colorless glassy bead like this. As soon as you have formed this, what do? You dip this into the sample which is under analysis. Now, when you dip, what will happen? This sample which is under analysis will be developing a coating or it will form a surface on this glassy bead. And then when you heat it again, what happens? So you can see this results. So if the flame, different flame, different color can be seen. Okay. Example, if the flame is oxidizing, Acha, are you aware of oxidizing flame and reducing flame? What do you mean by oxidizing flame and what do you mean by how do you identify this? Tell me. Hmm?
No, sir.
Okay. See, have you seen the welding and all going on? Hmm?
Yes, sir.
Like oxidizing flame may you require excess of oxygen. Understood. And like how do you characterize that? Have you performed qualitative analysis in lab?
Yes.
So have you seen this blue flame and yellow flame? Hmm? Tell me. Like टीचर्स बोलते हैं ना कि येलो फ्लेम दिखेगा रेड फ्लेम दिखेगा आर यू अवेयर ऑफ दैट सी व्हेन इट इज ऑक्सीडाइजिंग फ्लेम इट विल बी कंप्लीटली ब्लू कलर फ्लेम कैसा दिखता है वो हाउ डज इट लुक लाइक blue flame yellow flame have you seen that like when
Yes, sir.
burner when you ah so when it is blue flame no it is called as oxidizing flame what do we call it tell me oxidizing flame is that clear understood or not and जब वो it is yellow when it is yellow so at that time it is a kind of reducing flame in that case ठीक है if you have to identify how because oxidizing if you go by definition then oxidizing flame is what then oxidizing flame is the one in which excess of oxygen is present okay by definition but again if you have to perform this in lab then how do you identify oxidizing flame and non and reducing flame so blue flame if it is there it is called as oxidizing flame and if you adjust the burner have you ever used Bunsen burner on your own have you maintained the knob
Yes, sir.
yeah so if you change the orientation of knob the color of the flame will change and the like height and all of the flame also changes the intensity of flame changes right is that clear so anyway like that is not related to us as of now what is related is basically when you do this test when you perform this borax bead test what will happen so you'll what we do so first we heat borax then the glassy bead is formed then we dip that glassy bead in the analysis sample, and then again a coating of sample is formed on the glassy bit. Then again we heat it. So in that case, if you heat, okay, if you develop any of this color, blue or green, if it is oxidizing flame, and if it is blue color in cold, or if it is green in hot, in this medium, okay, then which ion is there? Cu plus 2 ion. Okay, this same logic is applicable for reducing flame also, but the observation will be different. If it is reducing flame in cold condition, the color will be what? Red opaque. Now, color of what? Color of that bead. This is the color of bead. Okay, whatever the colors we have mentioned here, this is the color of bead. Is that clear? Similarly, if you go for, let's say, cobalt ion, which ion? Cobalt. So in all the cases, cobalt ion will show which color? Blue color. It will show which color? Blue color. Is that clear? अब किसी को doubt आ रहा होगा. So if it shows blue color in all the cases, then how do we differentiate? Alright, that is one of the steps. Are you getting my point? So it is just one of the confirmatory steps. Okay, acha, no, not confirmatory. It is just one of the analysis steps that okay, cobalt can be present. If blue color is there, it means CO plus 2 ion can be there. Now, to confirm cobalt, we have different tests as well. Are you getting my point? So borax bead test is one of the uh, initial steps to identify which ions can be present, just to check out the probability. So if we get blue color in all the flame, it is possible that it is which one? It is Cu plus 2 ion, cobalt plus 2 ion. Is that clear to all? So this is how we use borax bit test in qualitative analysis. Anyway, it is not related to us. We are not going to focus too much into that. Okay. We just need to know how do we get borax, like how do we form borax bead. Just by heating the borax powder, it loses water crystallization, and then when you heat it further, we obtain what? Sodium borate, metaborate, and boric anhydride. Is that clear? Combined, they are called as borax bead. This is what you have to remember. Okay. Now, color of the bead is due to the formation of metaborate of the metal. This is very important point. Okay. And this is always going to combine in this fashion only. So, MO, metal oxide plus B2O3 will give us MbO2 twice. And what is this called as? It is called as metal metaborate. If it is cobalt, if this metal is cobalt, CO, then it will be called as cobalt metaborate. Is that clear to all? So when borax is heated in a Bunsen burner flame with cobalt oxide on a loop of platinum wire, a blue colored cobalt metaborate is formed. What is this called as? COBO2 twice is called as cobalt metaborate. Is that clear? So whenever we have metal oxide and along with that we have B2O3 reacting with each other, what do we end up with? We end up with metal metaborate. Is that clear or not? What do we end up with? We end up with metal metaborate. Example, the name of this compound will be what? Cobalt metaborate. Is that clear to everyone? This is your borax bead test. So in borax bead test, the final outcome will be what? So final outcome will be metal metaborate. What is the final outcome, guys, for borax bead test? What are we going to end up with? Tell me. What are you going to end up with? Bolo do.
Metal
What is this called
metaborate.
as?
Metaborate.
Metal metaborate. Yeah. Okay. So just now you saw. We don't need to discuss it. Straight away answer. Just now we are seeing borax on heating with cobalt oxide forms a blue bead of cobalt metaborate. What is cobalt metaborate? CO BO2 twice. No. See. Just now we see M BO2 twice. So here M is cobalt. So cobalt BO2 twice. Okay. Hmm? Can you proceed? Borax is used as buffer since why it is used as buffer? Yes, which option will be correct? What is the buffer solution?
Sir, A.
Hmm? Which option is correct? Tell me.
Sir, A.
A.
A, sure, everyone. No one is saying C, no? C वाले तो कोई नहीं है ना यहाँ पे. मैं तो 50 C, sir. So, how do you identify a buffer solution? What is the characteristic of a buffer solution? That one of the electrolytes should be weak electrolyte, and then other one should be the salt of that weak electrolyte. Okay. ठीक है. Borax bead is chemically. Acha, what is the chemical formula of borax bead? So we all know sodium
D.
metaborate and
D.
B2O3 boric and hydride. Yes or no? So option D is correct. Okay.
Sir, why is
Borax
this
bead.
metal?
Sorry.
Oh, okay, nothing.
Sorry.
Nothing, sir.
Yeah. Now, the next compound that we have to study is H3BO3. What is the next compound? So, we are done with borax. Yes or no? Borax done. Now, we are going to study orthoboric acid. And the last one will be diborane, B2H6. Understood? Chalo. Acha, for borax, one thing is left. I don't know whether they have discussed this or not. ठीक है मैं बता देता हूँ एक मिनट let me just check whether something else is not going on. ठीक है borax में few points are not there so please mention write those points okay I'll write for you. So what are those additional points that we can write? Okay. So कहाँ गए? Fine. Few properties which we want to mention. So these are all properties. Okay, what are these? These are all properties. So हमने पढ़ा ना that borax is a white powder, something like that. White crystal solid. Yesterday, no white crystal solid it is. Just mention this point. Huh? So it is less soluble in cold water. Less soluble in cold water. But more soluble in hot water. But more soluble in hot water. Less soluble in cold water, but more soluble in hot water. Can anyone tell me why? Because the dissolution of borax is endothermic. Is that clear? So what do I mean by endothermic? It requires heat. No. So hot water will provide it some extra amount of heat that it requires. As a result, it is more soluble in hot water compared to cold water. Is that clear to everyone? Tell me. Yes or no? बोलो बच्चों समझ में आए so this point you have to remember like you better note it down because this is not there in PPT no so some additional point you should know about this. Can you proceed? Can you proceed? Tell me.
Yes, sir.
Okay. Next. जैसे अभी तुमने वो देखा टाइड का एड देखा है दिस एड यूज्ड टू कम ऑन टीवी एंड ऑल टाइड extra white have you seen that whitening ad and all basically all these detergents and all hmm? What do they have?
Yes.
They have some brightening agent. Yes or no? So in that also we use borax. Like how do we use borax? So when we heat borax, what do we get? We get sodium metaborate, no NaBO2. Yes or no? We get Na. इधर तो नहीं लिखा है कहाँ है NaBO2? हाँ यहाँ पे है ना. We get NaBO2, right? What is this sodium metaborate? NaBO2. So when we treat NaBO2 with what? H2O2. अच्छा, what is H2O2? Hydrogen peroxide. Hydrogen peroxide, no? Along with H2O liquid. What do we end up with? So when these two combine, acha, H2O2 is here it is acting as oxidizing agent. Here it is acting as what? Oxidizing agent. So what do we get? We get this compound Na2, okay, then OH twice B, then OO. Acha, ये OO दिख गया. This is which linkage? Can anyone tell me which linkage it is?
Peroxide.
Peroxy linkage. OH twice dot 6H2O. Is that clear? Now this compound is called as sodium peroxoborate. What do we call it? We call it sodium. The name of this compound is what? Sodium peroxoborate. What is the name of this compound? It is called as sodium. गड़बड़ हो गया थोड़ा स्पेलिंग का पर ऑक्सो बोरेट BORATE it is what it is BORATE sodium peroxoborate. Is that clear? And what is the role of this? It's a brightening reagent. Okay, what is it? It's a brightening reagent, or you can say used as brightener. Used as BRIGHTENER. Used as brightener in what? In detergents. In what? Detergents. Okay. So this is one of the important point. अच्छा इसका स्ट्रक्चर भी अगर तुमको चाहिए तो लिख सकते हो. Proxy linkage है ना. So OO. So here we have B. Then OO. Then again B. Okay. Then here OH. OH. Here also OH. And then OH. Okay. हो गया ना देखो कितना टोटल 4 OH है 4 OH sorted. There are 2 peroxy linkage levels sorted. And then overall charge is -2. Basically Na plus 2 Na na. So it means this will have -2, Na will have +1. So 2 Na plus, and this overall complex has -2 charge. Okay. So, acha, what is the hybridization of boron in this case? In sodium peroxoborate. Yes, what is the hybridization of boron?
sp3.
sp3. Very good. It is sp3. Okay. So that's it. And then there are few uses of boron that also we can write. So one of the uses that we saw it is used as borax bead. So we can do qualitative analysis, right? Has everyone noted this? Sodium peroxoborate wala? Then or not?
Done, sir.
Okay. Okay. So what are the uses? First uses is what? That it is used in qualitative analysis for performing what? Borax bead test. Then have you heard that kahavat or proverb? Sone pe suhaga. That's a Hindi proverb. Have you heard of it? Sone pe suhaga. Hmm? No one has heard? Do you know what is
Yes,
sona?
sir.
Sona means gold. Sona means what? Gold. But do you know what is suhaga? So borax in Hindi is called as suhaga. What is it called as? Suhaga, Sone pe Suhaga. So, gold, in the purification of gold, we use borax powder. Is that clear? So, one of the uses is what? Like, one of the uses is borax bead test, qualitative analysis. One of the uses is what? Borax is used to purify gold. So, how do you remember that? Sone pe Suhaga. Okay, so one of the uses is what? It is used to purify, used for purification of gold, used for purification of gold. So this is second application. And one more application is what? It is used for the production of glasses. Okay. First is what? Used for borax bead test, qualitative analysis. This is second one. Used for purification of gold. And third is what? Used for glass production. Okay. Used for glass production. Sorted. So these are some additional points that you should know. I hope it is clear to everyone. बोलो समझ में आ गया? Now we can proceed with the other compound. Yes, guys, tell me. Shall we proceed?
Yes, sir.
Oh, sure. This is done. So good. Now, the next compound is orthoboric acid, right? This is our next compound. What is the next compound? Orthoboric acid. Sure. Now we'll study orthoboric acid. So, The first point, अच्छा orthoboric acid H3BO3 भी लिखते हैं और इसको BOH thrice. We can also write it BOH thrice, also called as boric
Sir,
acid.
sir, what is the third use?
Production for glass, like it is used for the production of glasses. Borax can be used for the production of glasses. Total three application you can see is for purification of gold. It is used in qualitative analysis as borax bead test, and the production of glass also. Borax is required. Okay. Then, so
Yes,
first of all, what is boric acid? So it's a white crystalline solid with soapy touch, sparingly soluble in cold water but highly soluble in hot water. Okay. Boric acid is a weak monobasic acid. And this is very important point. Boric acid is a weak monobasic acid. What do I mean by monobasic acid? That it will generate one H plus only. Monobasic means what? It will generate only one H plus. Acha, if it is generating H plus, it means is it donating H plus? No. Generating and donating is different. Donating means it is donating of its own. Generating means it is arranging H plus from the medium somewhere, from somewhere in the medium. Is that clear? There is a difference. Are you getting my point? Now, how does it take place? Because if you remember at the start of the chapter only today, after half an hour, I guess, I was discussing this Lewis acid, the concept of n factor. I was asking, what is the n factor of H3BO3 and all. Do you remember that? Only one of you told, someone told, हाँ sir, उसका one होता है. But how do we know it is one? The thing is, it is not a Lewis, it is not a protonic acid. Protonic acid are the acid which donates H plus. Does it donate H plus? The answer is no. Then how do we get H plus? It is a Lewis acid. So it will take OH minus of water and donates H plus. If you see in this reaction, this is Lewis acid. What is this? This is Lewis acid. And we have H2O, no? So boron has vacant orbital. B, OH, OH, and OH. And here you have vacant orbital. Now what happens? So we have H, OH. So this OH will go and attack in the vacant orbital of boron. Yes or no? And then that is how H plus is released, because this oxygen will now form three bonds. It will develop positive charge. Positive charge on oxygen will be unstable, so it will release this H plus. Sorry, it will release this H plus like that. Okay. Now, therefore, we end up with what? BOH4 minus and H3O plus. अच्छा, H3O plus कहाँ से आ गया? Because we have taken two H2O, no? So H plus, na, H plus and hydronium ion are equivalent. Like this is equivalent to H plus only. They are same only. Hydronium ion and H plus ions are same. Is that clear? Okay. So these are the some introductory points that you have to remember about boric acid. First, it is what? White crystalline solid and it has a soapy texture. Okay. Next, sparingly soluble in cold water but highly soluble in hot water. I already told you even borax was like this only. What is the reason behind that? The reason is that dissolution is what? Endothermic. Is that clear? And the most important point is boric acid is a Lewis acid. What do I mean by Lewis acid? It will accept electron pair in the vacant orbital. Okay. And it will accept electron pair, therefore it is Lewis acid. But it is at the same time, it is accepting electron pair from water in the form of OH minus. So water releases H plus. I told you it is not protonic acid. Protonic acids are those acids which will donate H plus from its own molecule. Here, boric acid is arranging H plus from a water molecule. It is not donating its own. It is arranging H plus from a water molecule. Therefore, it is not a protonic acid. It is a Lewis acid. Understand the difference, okay? Chalo, moving on. Now, how do we prepare orthoboric acid or boric acid? So, first method is what? By acidification of borax. By acidification of what? Borax. Aqueous solution of borax, actually. Is that clear? So, either you treat it with HCl or H2SO4. Okay. And aqueous solution is what? Water is already there. You can see this, no? Laser. Let me use this. Yeah. So, when we treat aqueous solution of borax with acid like HCl or H2SO4, what do we get? We get boric acid. What do we get? We get boric acid. Acha, when we are using NaCl, we are going to HCl. When we are using HCl, we are going to get NaCl. If I would use H2SO4, I would get Na2SO4. Is that difference clear to everyone? But the main product is what? Boric acid. Main product is what? Boric acid. Is that clear? Yes or no? Tell me. Acha. Now, now next is what? Uh, it is also formed by hydrolysis reaction with water or dilute acid of most boron compound like trihalide or hydrides. Acha, if you see BCl3 is here, it will react with H2O, it will give us H3BO3 and this 3HCl. But this is not the whole reaction. Is that clear? Is this the whole reaction? The answer is no. This is not the whole reaction. Okay. Now, how does the whole reaction takes place then? Look, no, for BCl3, it is the whole reaction. For BBr3 also, for Bi3 also, but not for PS3. What do I mean by this? When I'm saying that, hydrolysis of trihalide will take place, resulting formation of boric acid. But I'm saying it will be done for BCl3, for BBr3, for Bi3, but not for BF3. Okay. Because note करके write down BF3 does not show complete hydrolysis. What? So I have to write down in the form of note. NOTE note that BF3 don't show complete hydrolysis. BF3 don't show complete hydrolysis. Now what does it mean? आगे दिया है, let me check. Once more again. चलो. See, so how do we like what is complete hydrolysis? What do you mean by complete hydrolysis? So what do I mean by that is the thing is देखो होता क्या है BF3 केस में we have BF3 we'll treat it with H2O. We're going to end up with H3BO3 plus 3HF. Okay, now is the reaction balanced? The answer is no. 6. Now it is balanced, right? Yeah. So this is the product that we have obtained. But what happens is that the BF3 which is formed, okay, sorry, the HF which is formed, it reacts with BF3 again. So BF3 plus HF. What do we get? We get HBF4. Do you remember this HBF4? Very famous it is. Where you have studied
आठ में बम
HBF4?
फूटा 4 बार.
Shabash, Avnish, expected. I was expecting your answer. Very good. Yes, others. HBF4, have you studied or not in reaction mechanism? The reaction of benzene diazonium salt
That
for
was
formation of
benzene.
fluorobenzene. Yes or no? ARSN1
Yes.
reaction. Yeah. So HBF4, you have studied that. So the HF which is formed in the product in the first step reacts with BF3 again. And what do we get? We get HBF4. 3 HBF4 we are going to get. Now when we add this reaction, what do we get? So you can see the reaction is non-balanced. 3HF, 3BF3, 3HBF4. So balance again. 3 ठीक है. So HF and HF will be cancelled no, if I add both the reaction. Tell me. बोलो yes or no. So होएगा क्या? तो 3 plus 1, 4 BF3, okay, plus 3H2O gives H3BO3, H3BO3 plus 3HBF4. This is the overall reaction. Now, if you see the product, like the reaction, the ratio is what? 1:3 formation. कैसे बन रहा है वो? For 3 water molecule, okay, we are going to end up with 1 boric acid. So the ratio is what? 1:3. What is the ratio here? The ratio is 1:3. Therefore, in case of BF3, we say that it does not undergo complete hydrolysis. Just remember this note and the reaction. And what is the ratio for BF3? 1:3. For 3 water molecule, we are going to end up with 1 boric acid. Is that clear to everyone? बोलो बच्चों.
Yes.
But what about chlorine, bromine, and iodine? Will they undergo complete hydrolysis? The answer is yes. The answer is yes. They will undergo complete hydrolysis. Chlorine, bromine, and iodine will undergo complete hydrolysis. Is that clear? Tell me. So यहाँ पे it is also formed by hydrolysis reaction in order to hydrolysis of glucose. अच्छा B2H6 B2H6 का भी रिएक्शन दे रखा है इधर यहाँ पे इन लोग ने. So when B2H6 reacts with H2O, In that case also we end up with boric acid formation. In that case also we end up with boric acid formation, also releasing of hydrogen gas, H2 gas. So please remember that as well. Okay, bachcho? One point which is not here, that also we need to write. One more method of preparation is there for boric acid. Okay, let me check. आगे तो नहीं दे रखा. Or do we have? ये तो नहीं. ठीक है. Okay, start given. Space is not here. ठीक है.
What's
In
there?
chemical bonding, have you studied? Sorry,
What's there in the previous slide?
this
Before
one.
this. Before.
Before this.
Oh, this. Okay, now my this. Nothing.
Okay.
Sir, could you
Uh,
like wait in this slide for a minute?
Sorry. You want me to wait on this slide?
Yes, sir, 1 minute.
Yeah, noted. If done, please let me know. Okay.
Yes, sir. Done.
Okay. One more method of preparation is there. Before that, we'll discuss the structure of S3BO3. You know that it has a like layered structure. What do we have? It has a layered structure. It has a layered structure. Is that clear? And why it has layered structure? Because it undergoes extensive hydrogen bonding. You would have studied this in chemical bonding. Have you studied this or not? This undergoes extensive hydrogen bonding and it forms a layered structure. Okay. So please remember this about the structure of S3BO3, that it has a layered structure, okay, in which planar BO3 units are joined by hydrogen bonds as shown. So the BO3 units will be in plane and they will be attached to each other with the help of hydrogen bond. With the help of which bonds? Hydrogen bonds. Understood, everyone? You know the sp2 in BOS thrice, S3BO3, the boron is sp2. You know that, right? Therefore, they have written planar. समझ में आ रहा है? How are they writing planar? Because the sp2 hybridized boron atom is present. No. Okay. Now the last method of preparation, or the one more method of preparation is what? ये क्या है? Heating effect. We'll see that later. Either you can write from colemnite ore. From which ore? From colemamite. Colemamite. Colemnite. Now, what is colemnite? It's a calcium ore. What is it? It's a calcium ore. So Ca2b6O11 along with SO2 gas and H2O liquid. We get Ca HSO3 twice. Now HSO3 twice क्या बोलेंगे इसको तो? By sulfite. Yes or no? SO3 ion is what? SO4 is sulfite. SO3 is sulfite. So HSO3 is what? Bisulfite. Calcium bisulfite is formed. Along with that, what do we get? We get H3BO3 plus H3BO3. Okay. So this is also one of the method of preparation of boric acid. So total, how many methods of preparation of boric acid we have seen? Yes, anyone? First method was by treating the borax with, aqueous solution of borax with acid like HCl or H2SO4, resulting in formation of boric acid. Then we saw hydrolysis of BX3. And in BX3 hydrolysis, see here, these two methods of preparation we have seen. No, in hydrolysis we have mentioned strictly that except fluorine, all undergoes complete hydrolysis. Fluorine undergoes partial. Basically, it's not complete hydrolysis, right? Why? Because the ratio is 1:3. For 3 water molecule, we end up with only 1 boric acid. Is that clear? Tell me, guys. So for BF3 ka case, you have to be careful. And the last method was from calamnite ore. Okay, from calamnite ore. In that, what do? We treat calcium wala ore with SO2 gas along with like aqueous solution of that ore, and we end up with boric acid. Please remember this as one of the methods of preparation. So the preparation methods for boric acid is over. Now what is this? This is heating effect. What do we call it? We call it heating effect. Sorry. So when you heat it almost how much? Almost 100 degree, 97 Kelvin. And 97 degree means what? 100 degree only almost. So when you heat it at almost 370 Kelvin, heat what? Boric acid. When you heat, what will happen? Water molecule will be gone. So when any acid loses water molecule, it becomes metaic acid. What does it become? It becomes metaic acid. So from boric acid, it will become metaboric acid. Is that clear? HbO2. And if you heat it further, what will happen? It changes into boric oxide, B2O3. So remember this. This is called as heating effect of S3BO3. So on heating, what will happen? First, it will get converted to metaboric, and then finally it will form B2O3, that is boric oxide. Okay, moving on. When borax is dissolved in water, what happens? Tell me. Yes, when we dissolve borax in water, what happens? Na2B4, also aqueous solution of borax is what? It's a buffer solution, no? Borax is dissolved in water means what, guys? It's a buffer solution, aqueous solution. And what is present in buffer solution? Weak acid and
Salt.
its salt. So salt ka both the ions are not given. Only one ion is given. Which option will be correct? Tell me. It should not take this much time. अरे ऑप्शन सी करेक्ट है ना बच्चों. Tell me. We have studied no aqueous solution of borax. हाँ.
Sir, but how is it
तो
forming BOH4? Like whole.
ये देखो कहाँ है aqueous solution of borax. What is this? Just read this like. Yes, Nishan Shashimat, you were there, no?
Oh, yes.
Understood? And anyway, it's a very famous example. Aqueous solution of borax, it forms buffer solution, acidic buffer solution, H3BO3 and NaBOH4. Understood? So Na plus is removed, therefore they have written as BOH4 minus.
Sir, but
Understood?
normally also boron does not form like that MOH4, right? Like hydrolysis thing.
Boron can, that's a different, like, MOH4 is a different, like, complex formation it is. Okay. When we are talking about MOH4 and MH2O6, that is complex formation. That boron does not form. Here, boron is accepting electrons. See, hydrolysis will take place, no, for boron.
Yes.
So it will take OH minus. So that it is receiving OH minus. Is that clear in this case? When it is forming BOH4 minus, it is receiving OH minus. That when I was discussing about this thing, kahan gaya? Not this one. N factor wala concept. Just do that. This thing. Can you see this? What I've discussed over
Yes.
here. What is this? BOH4 minus. No, it is accepting
Oh,
electron pair from OH minus. Understood,
okay.
Nishan?
Yes. Yes, I got it.
Okay. So here the correct answer is option C. Very famous example. I was expecting everyone to answer this because from like at least 4 or 5 times I have repeated. Aqueous solution of borax is buffer, acidic buffer. Aqueous solution of boron is acidic buffer. We have done this in ionic equilibrium. This only I have repeated twice or thrice. Please be careful. Okay. Yeah. See, one explanation is given like that. When borax is dissolved in water, what happens? What do we end up with? We end up with H3BO3 and NaBOH4. So therefore, it is an acidic buffer. Which of the following statements about H3BO3 is not correct? It has a layered structure in which planar BO3 units are joined by hydrogen bond. Is this statement correct or incorrect?
Correct.
Is this statement correct? Because I told you all the boron atoms are sp2. Therefore, the structure is planar. And all of them have layered structure because they have hydrogen bonding going on. And just now we saw in this example. Can you see that? Just read this line. It has a layered structure in which planar BO3 units are joined by hydrogen bond as shown. So the first statement is correct. Okay. What about second statement? It does not act as proton donor, but act as Lewis acid by accepting hydroxyl ion. Do you believe it is correct?
Correct.
Yes.
Very correct, because just now we saw that it is not a protonic acid, it is Lewis acid. But still the N factor is 1. Why N factor is 1? Because it takes OH minus from water and donates H plus of water only. But only one H plus it can donate. So it is monobasic. Only one H plus it can donate. It means what? It is monobasic. The third point says it is tribasic. So it is correct or incorrect?
Incorrect.
The incorrect.
Tri tribasic means it should donate 3 H plus. Will it donate 3 H plus? The answer is no. It will donate only 1 H plus. And that too not its own. That H plus, the H plus which it is donating, boric acid is donating the H plus. Which H plus? That H plus is coming from water. That H plus is coming from where? It's coming from water, no? अरे बोल दो. Hmm? Say yes or no. Just now we discussed this. यार.
Yes, sir.
देख. हाँ, अभी देखा. देखो इसको. Be active. Yeah. So इसका correct answer is what? Option C. Because they are asking incorrect one, which is not correct. So third one is not correct. Acha, what about fourth? It is prepared by acidifying an aqueous solution of borax. So it is one of the method of preparation. Total 3 methods we have seen. No. First method is what? Aqueous solution of borax is treated with acid, right? So that is given. Option D is that only. No. Can H3BO3 be prepared by this method? The answer is yes. We have studied two more methods. One was colimnite ore. When colimnite ore was treated with what? Tell me. We treated colimnite ore with what? To prepare H3BO3.
SO2
जल्दी
and
बताओ.
H2.
वेरी गुड. किससे हमने ट्रीट किया उसको? SO2 and H2O. अच्छा, and what was the third? Like one more method. Polyamide to we studied last. Third actually. Second one was which one?
Hydrolysis.
Boron trihalide का hydrolysis. And in that we studied that BF3 undergoes partial hydrolysis. BF3 undergoes what? You know, it does not undergo complete hydrolysis. The ratio is 1:3. Remember that for 3 water molecule we end up only with 1 boric acid for BF3 case. Sorted? Hmm? Okay, moving on. So next ये भी हो गया. Boric acid is an acid because its molecule. बताओ. Why is it acid?
So C.
Option C,
Just
right?
a
Accepts OH minus from water, releasing proton. Very good. Next. Orthoboric acid when heated to red hot. Red hot means at a very high temperature. It gives. In heating effect of boric acid we studied. First it gives metaboric, then again it gives boric oxide. So if you heat it continuously, what will it give? Hello, metabolic or heated to red hot means very high heat. What will it give? Tell me. Huh? Boric, no. अरे देखो इधर लिखा ना. If you heat it like at red hot, मतलब see 100 degrees not red hot, okay? Whenever they say red hot, it means it is very like above 500, 600, 700, like that temperature it is. Is that clear? So when we heat it first, where we get metaboric acid, and when we heat it further, we get boric oxide. Okay. Structure of boric acid is H3BO3. What will be the structure?
D.
D.
क्या है? Tell me properly what should be the correct answer. Yes. Abhi just now we studied, no? Boric acid H3BO3 has a layered structure. All the BO3 units are in plane and they are attached to each other by which bonding?
H bond.
So which option will be correct?
D.
Yeah. Now diboron. But before diboron, there are a few more points that we need to note it down. Okay. Diboron is the last compound that we are going to discuss for boron. After that, we are going to discuss for aluminum. Okay. But before that, few more points for this molecule. Boric acid. Okay. H3BO3. Okay. Sure. Now, total how many points we have discussed for boric? Where the slide का जगह कहाँ पे? First, I have to see that. This is only what we have discussed. 。 . 。 。 。 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 。 . 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 . 。 。 . 。 . 。 。 . 。 . 。 . 。 one of the very important, like this you would have you studied this in ionic equilibrium that we don't use H3BO3 for titrations. You know, you have studied the titration in ionic equilibrium, strong acid, strong base, strong acid, weak acid, weak base, weak acid, strong base. Have you studied this or not? Hmm? बच्चों तुमने titration, have you studied titration in ionic equilibrium, yes or no?
So we did
Obviously you would have
titration,
studied.
but we didn't do why boric acid isn't used.
Because we don't do. So write down the note, third point, that boric acid is a very weak acid. I don't have space, but चलो I'll still write. मैं यहाँ पे लिख लेता हूँ. ठीक है. So it is one of the note only. You can write it in the form of note. What does the note says? भाई that इधर लिखता हूँ. Boric acid, ठीक है, is a very weak acid. Is a very weak acid. Okay. अच्छा इतना इसका pK is very less, almost 9. pK is approximately how much? 9, very less. Okay. pK is very high, so therefore it is very less acidic. Therefore, cannot be used for titration. Cannot be used for titration with NaOH. With NaOH. Due to lack of steep section. No, that steep section gives us that range in titration curve. In titration curve or plot, whatever you want to call it.
So the pH
ठीक है?
doesn't drop that drastically, it just stays.
Yeah, so therefore, and therefore, no, like अपना क्या बोलते हैं कि the section is the plot becomes so steep that it becomes very difficult to calculate the end point. Is that clear? So I'll add one more point. Therefore, no proper determination of endpoint. No proper determination of endpoint.
So could you
Is
show
that
how
clear?
the graph would
No.
look in this?
What?
So could you show how the graph would look for boric
हाँ
acid?
ठीक है मैं दिखा देता हूँ. ठीक है. See, steep section like it is almost straight. Like it's like this. Like it becomes very difficult. This is how the graph generally looks for boric.
Okay, because NaOH will suddenly just increase the pH.
वो उसके कारण होता है कि you won't be able to find the endpoint in the plot.
Okay, yes.
Okay, but
Understood.
see, what you have to remember for boric acid is, just a minute. I need to take this. Hello. मैं मेरी क्लास है तो बता दूँ. मैं वो क्लास चलती हूँ मेरी. आप मुझे लिंक भेज दें क्लास ऑफ वीडियो ज्वाइन कर लें. ठीक है. कितने बजे आएगा वीकेंड कितने बजे? Yes, बच्चों. So what you have to remember for boric acid? Tell me that there is no proper determination of endpoint. So therefore it becomes very. कौन है भाई? किसका माइक चल रहा है भाई? Don't be antisocial element. You don't know me. ये कौन दिख रही है? किसका माइक चालू है? किसका माइक चालू है? See, who- whoever it is, see, whoever this is, जो भी है ये, if I get to know, तो जिस भी स्कूल में पढ़ रहे हो वहां पे आके मिलूंगा मैं तुमसे. Okay, and definitely will get to know who is doing this. You contact your parents as well. Anyways, 11 o'clock it is. For others, the class is over. Okay, you can leave the meeting.
Thank you, sir.
Thank you,
Thank you,
sir.
sir. Thank you, sir. Bye, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.